Hello. Can someone give me access sa breakout room? Wait, ito ba yung breakout room na nasan sila Macy?
Yan.
Okay.
Hello, hello. Uh, Good day, everyone. So I know I think we're still all ACM mems here, and aside from Ma'am Christine. But however, we'll be starting our program in a few minutes. So in the meantime, make yourselves comfortable, get some snacks, or fasten your seatbelts to prepare for our travel this afternoon. So, thanks, guys. See you later. All right. What up? What up? Good afternoon, everyone. So, hi guys. We're gonna be starting our program. So, ready na ba kayo? So good afternoon, everyone. We are your hosts, Josh and Macy, and we'll be your fellow journeymen for this year's ACM Fest 2022. And as they say, it's all about the journey and not the destination. So in this year's ACM Fest, we'll be exploring how the technologies we have today evolved to what they are now and witness the first steps of pioneering technology firsthand.
We'll also learn more about the usefulness of existing technologies that we use on our own personal journeys along the road of life.
Right, but before we start this engine, we'd like to express our gratitude for you, our audience, and for joining us in this adventure into our lovely partners and sponsors.
The UP ACM Fest 2022 Destinations by the Association for Computing Machinery UP Diliman Student Chapter is co-presented by freelancer.com
In cooperation with White Widget, Expedoc Software Incorporated, Avaloc,
and also brought to you by Course Hero and Navitaire Philippines Incorporated.
and also sponsored by Point West Innovations Corporation, Asus Systems Philippines Limited.
Supported by our media sponsor, Monster RX 93.1.
And with special thanks to Tech Factors Incorporated. Yo, ang dami sponsors. Let's go.
Let's go.
All right. The journey of 1,000 miles begins with a single step. And what better way to take our first than to hear the words of encouragement from UPACM's captain?
Let's tune in to our chairperson, Luis Gabriel Agana, as he delivers the opening remarks with a warm virtual round of applause.
Let's go, Luis.
Hello and good day to everyone. I would like to welcome you all to this year's ACM Fest, the year-ender event of the Association for Computing Machinery UP Diliman Student Chapter, or UPACM, where we will be able to gain new knowledges from various talks and then ending it off with some fun and games. This event wouldn't have been possible if it weren't for our sponsors, some of which have representatives who will be giving us talks later on in the event, and of course to UPACM for working tirelessly these past few months to make this event a reality. Given the setup that we have today and considering the current situation, things are a bit quite smaller scaled compared to last year. But it's still going to be the good old wonderful, insightful talks from our dear speakers, which I hope everyone will enjoy today and may we all get to learn something new. Again, welcome everyone to ACM Fest and hope you all have a good time.
Thank you, Luis, for those welcoming words to start our travels today.
And now we're all set. We now introduce our sources of information for today's destinations.
Now let's start off today as strong as possible. We introduce our first speaker.
She is a distinctive alumna of UP Diliman, having graduated magna cum laude with a bachelor's degree of science in computer science back in 2015. She also graduated with a master's degree of science in knowledge service engineering at Korea Advanced Institute of Science and Technology in 2018.
Now she's a machine learning engineer working on personalization at Canva.
She was previously a data science consultant with experience across a diverse range, including mining, retail, media, and commodities trading.
In fact, she also served as UPACM's chairperson during her last undergraduate year.
Let's all welcome our guide to the first destination, a familiar face returning back to ACM Fest to the talk on personalization in web applications or machine learning, Ms. Christine Balili.
Hi. Hello, good afternoon. To start with, I'm going to share my screen. If you will allow me to share my screen. Awesome. So hi again, everyone. Thank you all for tuning in to this talk on a Saturday. What a wonderful way to spend your Saturday afternoon learning about new things in the industry. That's really admirable for you to do that. And I hope you've been having a splendid Saturday so far. So my talk today is entitled Enabling Personalization in Products Through Machine Learning. It was originally entitled Enabling Personalization in Web Apps, but I thought it might be more generic to just do it for products, because products can take many shapes and forms, and personalization can be in many shapes and forms throughout different platforms as well. And as mentioned in the introduction, I am a machine learning engineer. I currently work for Canva. I have over 4 years of machine learning experience now in the industry. And I don't know if you know, but Canva is a product for design. Our mission is to enable the world to do design. And so if you're students, you actually can go on Canva and create presentations, videos, all these document types, posters even. You can get it for free if you are a student for Canva for Education. So I work as a machine learning engineer, personalizing the user experience for our Canva users. So you can see when you log into Canva, there's this For You section, which shows you categories that you might want to try. And that's kind of some of the surfaces within Canva that I work with in terms of personalization. So that's just a very quick flavor of what I do. So as mentioned before, I was a former data science consultant and a data scientist for a retail company in Australia. So I worked a lot in e-commerce, trying to recommend products to people that they might want to buy. I also worked in time series forecasting for sales to sort of optimize store operations. And before that, I was a consultant. So I did use cases in mining, sales and marketing, commodities trading. So that kind of sums up the last 4+ years of working in machine learning in the industry. But prior to that, I was doing research in South Korea for 2 years as a master's student. I actually wrote a couple of articles related to complex network analysis and combining machine learning applications to that work. So if you're interested, you can read on some of the papers that I wrote on that. But yeah, coming back to ACM, this is very special. I used to be behind the scenes organizing these talks when I was a student. We would do it in real life. I think now with like everything that's happening in the world, it's quite good that you can do this like without having to rent a room. You can just do it online and actually have a broader audience to work with rather than just having people come in person. So this is kind of very special to me, and I'm always thankful that to be given this opportunity to share what I know to students, to inspire them to maybe take up a career in machine learning when they graduate CS. So yeah, that's just a little bit about me and my work in personalization. So in today's talk, I'm going to be covering 3 things. So number 1, I'll define what is personalization and what is machine learning, just as an introductory concept. And number 2, I'll do a little bit of introduction to machine learning for personalization use cases. This is not going to be very technical. I'm not going to go into like super detail on the algorithms, but I'll give you like a flavor and high level overview of some of the machine learning techniques that are used in this space. And in the last part, I will talk about how do you actually make this work in practice? How do you enable machine learning based personalization in products or in web apps? I'll talk about like the fundamental requirements, what needs to be in place in order to enable that. And I also talk about a sample solution architecture. So I have a specific use case and I'll go through what are the elements and what that need to be in place and the processes that need to be in place in order to support that particular use case using machine learning. This is a very high level talk, but if there are concepts that you are interested in, you can ask me at the end of the talk as well. So yeah, let's jump right into it. So what is personalization? So personalization is simply the process of enabling the users to find content and features in the product that might be relevant to them based off information that we know about the user and information that we can infer about the user. So I've written here, it is the process of providing tailored messages and user experience to a user over time. So there's 2, I guess, keywords: tailored, meaning no 2 users have the same experience because no 2 people are very similar. So like it's unique, the experience is unique to the user. And I've also pointed out that it's over time. So personalization is not a one-off thing. You learn more about the user as they continually engage in the product. So like, for example, right, Facebook, it's an app that we all use, I think. Most of us have Facebook. So the longer that you use Facebook, the more personalized your experience gets. And like whatever you have from last year will slightly be different from what you have this year because it reflects your evolving interests and also your evolving, I guess, patterns of usage within Facebook. So it's kind of how personalization works as a concept. Now, the other end of the equation is machine learning. So personalization can be done without machine learning, but for this particular topic, we're interested in how machine learning applies to personalization. So machine learning, I'm sure it's like at this point, like every CS student knows about it. Before it was just like some niche topic that people in CS are interested in, but now it's kind of like became the hype, like the big, like everybody who does CS at some point wants to make games. Now, I think the other reason is they want to do machine learning or AI. So yeah, as you all know, machine learning is the use of algorithms that learn patterns from historical data to make an inference or generate predictions. So there's two keywords there, algorithms, and I think the other keyword should be data. You need big data to do that. And then the third keyword is generating predictions or generating inference. So in combining these two concepts together, you then get what's called ML-enabled personalization, which is just the use of algorithms that learn from user data to create a customized or tailored content and experience for the user over time as they engage in this particular product or particular app. So yeah, that is how we define personalization as a concept and how machine learning gets infused into that. So I think before we jump into the details, one thing that we would like to ask ourselves is, why should we personalize in product? Like, why do we care about personalization? So if you are building a product, maybe it's a web app or it's a mobile app, we care about personalization because we want to keep our users engaged. And this has been proven over time, over many different successful products in the world, that if you try to make the content and feature as relevant as possible to your user, then they will continually use it. It's the reason why you keep coming back to Instagram, to Facebook, to TikTok. It's because the algorithm that they're using is very like tailored to you. They know what you like and they know new things you might like. That's why you keep coming back. So we want if you're building a product or building an app, you want your users to be continually engaged and you want them to keep coming back to your product. So it increases user engagement and it increases user loyalty. And if you're an app or a product that tries to sell something, so maybe I'll think about, in big example is Amazon, but I'll try to localize it in the Philippines, maybe Lazada or Shopee. So these like products or services, they want you to keep buying from them. So in order for you to keep buying from them, they have to serve you or show you products that are in line with your interest and you might like. So that's where personalization comes in, and it ultimately helps increase conversion. Conversion meaning people browsing to buying, that funnel. And then obviously the ultimate goal of this is to increase revenue. They want to earn money and continue to keep growing, and personalization helps a lot with that. So here, I think one thing I might want to point out here is that personalization is a spectrum. So here is like 3 high-level buckets of personalization, and from left to right, they're sorted from low to high level of complexity. And so there are 3 broad buckets. One is just rule-based personalization. The other is combining ML plus rule-based. And third is machine learning based. So a lot of the focus of my talk will be ML based, but I think I also would like to point out the 2 simpler use cases or 2 simpler modes of personalization. So one is rule based. So with rule based, all you need to know is a few data points about the user. So maybe it would be like, okay, what is the gender of this user? Where do they live? What devices are they logging on? Like what language are they speaking? Or maybe it's the user's birthday. So these are very like standard data points that an app would know about you. And based off of that, you can try to personalize the experience of the user. So it could be like showing them a homepage that is written in Tagalog if they prefer Tagalog as their language, Or if it's the user's birthday, maybe you can have a banner on the top of your homepage that says, happy birthday, blah, blah, blah. Here is like, I think Facebook does this when it's your birthday. They want you to like donate to a charity or something like that. So that's like very rule-based personalization. There's no machine learning involved there. You just take a data point that the user has told you and personalize your experience based off of that. And even though this is very simple, it's actually very powerful. Like showing what's popular in a user's locale or platform. Say, for example, you're in Quezon City and you're logging into Lazada. Maybe they will show you like, here are popular products in Quezon City or something like that. And based off of that, you as a user, because you live in Quezon City, for example, you can discover products that might be relevant to you because other people from Quezon City are also buying them. So quite powerful and very simple as well. And then over on the next bucket, we have ML and rule base. So basically, rule base is like if else, if you think about it. If user's birthday, then show this, else show generic experience. And then you have the ML and rule base, which is kind of like the middle ground. So I think a good example of this is what we call user segmentation. So user segmentation is the process of trying to infer what are some of the major user groups within your user base. So I don't know if you're familiar with this already. I don't know if they teach this at like third year CS, but there's this concept called clustering, where you basically take a lot of data points on individual users, and you try to find which users are similar to one another. So let's take, for example, an e-commerce website again. So maybe there are a bunch of users who can be classified as mommies because all they shop are like things that mommies would like, for example. Or there could be like, I don't know, early 20s millennial, no, not early 20s is not millennial anymore. It's probably Gen Z now. So like Gen Z shoppers, or there's like female, early 30s to mid 30s female millennials. So maybe these are like the different groups of people that are within your user base. And if you know what like group or segment a user belongs to, then you can try and personalize the experience for that group. So say if you're a young woman in your 20s, that particular segment, then they might show you things that are related to interest of people that are within the same group. So if the same group, like, I don't know, buys a lot of essential oils or yoga pants or mouse or whatever, all these like things that are interesting to young females in their 20s, then that is what you would see because you belong in that segment. So the machine learning part comes with discovering the different segments, because you don't know how many segments there are. You could go as granular or as high level as you want. And that's kind of where machine learning or clustering comes into the picture. And actually, when working with that type of use case, it's your job as a machine learning engineer or a data scientist to label what those clusters are. And then the personalization, the if-else part that we did earlier, comes into the picture after you've distinguished this cluster, because that's how you would try and like personalize the experience for the whole group or people belonging to that cluster. Cool. So the third bucket is ML-based, which is our focus today. And I'll just cite a few like use cases around this. So number one is recommender systems. Recommender systems are used everywhere on the web or on the internet. So like good example is Netflix. When you log into Netflix, you would see movies or series that are recommended for you. And that's all based off algorithms that try to infer shows that you might like based off what you've already watched before, or new shows that might be interesting to you because they're similar to shows that you watched before as well. So that's an example. YouTube is a recommender system. They recommend videos in the homepage. They recommend videos after you watch one video. So that's all recommender systems. And then there's the other use case, which is next basket predictions. So when you buy something from an e-commerce website, they try to recommend you new things to buy, predict what your next basket would look like. So for example, if you bought a computer desk, then maybe your next purchase would be a computer chair or a mouse pad or anything that might complement what you bought before. So that's kind of like the next basket prediction use case. And then there are things that relate to customer lifetime value. And customer lifetime value is basically how much worth you are as a customer to a company. So that would include things like you signing up, you using their product, you buying more, and eventually maybe at the end you stop using them. So the models that you use to across the customer's lifetime within a product, it could be you try to predict whether they're gonna churn. So is this user gonna deactivate their account within the app? Are they not gonna use my app anymore? So you try to predict which users are at risk of not using your app or disengaging. Then the second one, you can predict which users are going to buy more. So for example, I don't know, maybe you're a telco subscriber, you're using like a telco product, and you are currently in like a low tier subscription plan. So maybe you pay 500 pesos per month, but their algorithm finds out that actually this person can pay a lot more because they use this product a lot. So maybe we offer them a upgrade. So maybe we offer them a plan that allows them to pay us like 700 a month for more upgrades on certain features that they're using. So that's kind of the upsell part or a cross sell. And then the third one is campaign response. So say they're pushing a new feature in the app, and they want to know which among their users would likely use this particular feature. So they would try to model that and predict who among their users would sort of be interested in this feature, and they would push the feature on those that are predicted to take up or like use this particular feature that's new. So that's like a very high level overview of the use cases. There's plenty more, but these are the more common use cases that you would encounter working in machine learning within the space. So yeah, let's dwell on this ML-based machine learning a little bit more. And I'll give you a few examples, right? So I already cited Netflix as an example for personalization. So Netflix actually does personalization from top to bottom, from left to right. So whatever you see at the top here, it's not the same for everyone. Every person, every user in Netflix is a different like banner. And then the order of like the rows here are different. Like some people will probably see like trending now first before US TV shows, for example. And like the ordering of the shows that are seen here are also different per user. And that's all driven by the algorithms that they're using to personalize this homepage for the user. So the other things that they might personalize for you would probably be the images that you see. So like the thumbnails are different per user as well. So in I don't know, this particular Animal Kingdom show, my thumbnail is different from another user's thumbnail, for example. They do that level of personalization. And they can personalize as well the app notifications, so which shows they notify you on, and the emails that you get are also personalized because they know a lot about your viewing patterns, and they will try to make the content that they push to you as relevant as possible. And this is working very well for Netflix because a lot of the shows that people watch in the platform or in this particular service, 80% of those shows come from what is recommended to the user. So it's not organic, it's recommended by Netflix. And that's driving a lot of engagement for them, engagement and retention. Because like the more they recommend shows that might be interesting to you, then the more you're likely to come back and log into Netflix. And another example is Amazon. So I don't know if you have Amazon in the Philippines, but you can imagine equivalent platforms like Lazada or Zalora or Shopee, all these e-commerce websites. Fun fact, when I was in the Philippines, e-commerce wasn't a thing yet. And I actually did not experience e-commerce in the Philippines, but now I believe that it's a very successful, like people are selling online in the Philippines and people are buying online. So it's a very different world than I was in like 5 years ago. So yeah, Amazon does recommendations across its website, its app, and over email. So when you go to Amazon.com, you get recommended products right away in the homepage. And they would show, like, if you click on one product page, they would show like similar products that you might like. Or if you bought something, after you've clicked on purchase, they will show you, here are products that you might like based on what you purchased. So there's different levels of granularity in terms of their recommendations, but I'll show you here. They would feature like categories that you would like, and then they would recommend products based off the categories. So because I think I bought some kitchen product from Amazon before, they're recommending me a bunch of these things that are related to what I purchased. And this works out very well for them because about 35% of Amazon's total revenue comes from recommended products. So that's like a significant portion of the revenue that they're making within Amazon. So having cited those examples, I will now go to the second part, which is a quick introduction to machine learning for personalization. So very broadly, there's 3 buckets of work or ML techniques within personalization. So number 1 is supervised learning. Number 2 is unsupervised learning. And number 3 is reinforcement learning. Personally speaking, my experience is probably more on the first 2 buckets, which is supervised learning and unsupervised learning. The third bucket on reinforcement learning is kind of a more recent development within this field. And I think Netflix is actually using a lot of reinforcement learning in their personalization. So I'm not going to cover very much on that because I have no experience on that, but I'll talk a little bit more on supervised learning and unsupervised learning. So when we say supervised learning, that means you're building a model that is trained on data that has a label. So for example, when you're predicting whether someone is going to churn meaning they're not going to use your product anymore or not going to use your app anymore, you have historical data for that because you can determine previously which users have stopped using your app or churned. So there's a label. You would know whether it's churn or no churn. They're also that's more of like a classification supervised learning problem. There's also regression where you're trying to predict things like how much sales are you gonna get from a particular user? What is their lifetime value? So that would be like a regression problem. And you would also know like the label for that in your historical data because you can take users and their like purchase value in the past. So that's kind of an example along these lines. So for supervised learning, these are kind of like the predictive algorithms that we use. So there's a lot of tree-based methods like XGBoost, LightGBM, CatBoost. These are kind of like standard tree-based algorithms that we're using. And these tree-based methods work really well because 1, they're performant, and number 2, performant meaning they have pretty good accuracy, and number 2, they're explainable. So you can tell what are the top features or top variables that are driving your prediction, and that's helpful for people in sales and marketing. Because for example, if you have a model that predicts whether someone is going to stop using the app, and the next question you would ask is, why is this person at risk of leaving and not using the app anymore? And with tree-based methods, you can say they're gonna leave or stop using the app because of these reason 1, 2, 3. Maybe it's because they are experiencing financial trouble. So maybe they have missed payments or Or number two, they have stopped using the app for like a couple of weeks now, so they're likely not going to use the app anymore. So these things are helpful to know, because then you can sort of intervene and maybe like reach out to the customer via email, or some companies like try to call you and offer you a discount, for example, to keep you within the app and prevent you from churning entirely. So tree-based methods really work out very well in these use cases. And third one is deep neural nets. So there's methods like TabNet that allows you to use deep neural nets in order to do propensity modeling. But like in my experience with machine learning, a lot of my previous work is actually along tree-based and less so on the deep neural nets, just because of that requirement of explainability. So yeah, that's kind of all that there is on predictive algorithms. And I think you guys, being CS students, are mostly probably familiar with what I'm talking about. Otherwise, I can try to explain later. But if you take CS 180, like they will discuss decision trees in that course. And tree-based methods are kind of just like one level up your decision trees. Decision trees is like one tree, but then like XGBoost, like GBM, random forest, these methods are all like base of multiple trees. So that's the only difference there. The other bucket under supervised learning is recommender systems, like what I mentioned before in Netflix and in Amazon. So here we have methods like collaborative filtering, matrix factorization, and factorization machines. I'm probably going to touch on collaborative filtering and matrix factorization. So with, okay, so this was the churn use case I was describing earlier, where we're using XGBoost. Actually, let me just touch on this a little bit more. So in the first use case, where we are using predictive algorithms, particularly tree-based algorithms. This was an example. So you have user A and user B. You have different attributes about them. So you have age, tenure, how many minutes they're using the app daily. And then you have whether they're using a particular feature in the app. So these are all features or variables, and you can calculate them per user. And then your target variable is whether they will unsubscribe or not. And you're using an XGBoost model, for example, to try to predict that. And you can add an explanatory layer on top of your XGBoost that tells you like which factors are important to the model. So here we can say that the average daily time in app is a very good predictor of whether a user will unsubscribe or not. Because like the less time they spend on the app, the less engaged they are. So meaning they're at risk of not using the app anymore or unsubscribing. So that was like what I was talking about earlier in this part of predictive algorithms. Now I'll jump on to the second bit, which is on the recommender systems. And I'll probably like dwell on collaborative filtering as an example. So what is collaborative filtering? Collaborative filtering is a method that is used to generate recommendations. And in this particular example, the task that we're trying to do is we are trying to recommend products to a customer. And how we do that, we basically create a large matrix, CS130 or 131. I don't know what the number is, but in CS130, you will go through, I think, linear algebra, and you will learn more about matrices. So in collaborative filtering, you basically have a large matrix where each row is a user and each column is a product. So it's a user item or user product interaction matrix. And the value in each cell of the matrix represent how many times did user A bought product B, for example. So what we want to do is now try to maybe recommend new products to user A that they haven't bought before. So how we do that is we basically represent products as a vector of users. And so because you can represent that product as a vector, you can then calculate distances between products. So you have methods like cosine similarity, Euclidean distance, but we usually do cosine similarity. So you find items that are similar to each other based on their vector representation. So what you would get is something like this. So imagine the dots are products, and the dots are represented by a vector. And so you can find products that are similar or close to one another. And if user A already bought like this encircled product, for example, you can try to find products within the space that are most similar to them, or that are closest to them. So practically that would be like you're calculating the product to product cosine similarity, and you want to get products that have the highest cosine similarity to that product that the customer bought. So in visual terms, this would be the products that are in this particular square, and this is what you would recommend to that particular user who have bought this product here that is encircled. So that's kind of like the visual representation of that. And there are computational problems with collaborative filtering, right? Like you can imagine if you have 1 million users and you have like, I don't know, hundreds of thousands of products in your catalog, in your e-commerce catalog, that matrix could get really big and it's hard to fit that in memory. So there are methods that try to do like a decomposition. So meaning you, instead of this vector representation being like equal to the length of the number of users you have, they will try to decompose that into a shorter matrix. And there's techniques for that called matrix factorization. Basically, instead of it being length number to users, it would be like a length of vector k, where vector k is something that you set, something that you optimize. So maybe you can try to say that, okay, I will just use a vector of length 100 instead of it being like equal to the length of the number of users. So I don't know if you're familiar with those techniques, but like you basically encounter them in problems like clustering, where you encounter this problem called curse of dimensionality. Basically, if you have a matrix that is like quite large, like the number of items are, if you have a vector that has a large length, the distances kind of lose their meaning when you have such a very high dimensional vector. So what you want to do is try to reduce the number of dimensions so that your distances calculation would still mean something. So I'm not particularly sure if you guys are relating to this, but when you go to CS180 or CS131, these are concepts that you will likely encounter. Yeah. Cool. So that is a very like high level overview of how this all works. I will now jump into like practical application. How do you actually do this in real life? If you're like a machine learning engineer, how do you productionize a model? So there are a couple of foundational elements that need to be in place in order to enable this ML-based personalization. So there are 4 R. One is data. Obviously, you're doing machine learning, and machine learning works with big data, so you have to have data in place. And number 2 is infrastructure. So the algorithms that I cited before, they all need compute power. So you need compute to process your data, and you need to compute to train your machine learning algorithms. So that's where infrastructure comes in. And machine learning is the algorithms that I mentioned. So this relates to both development of the models as well as how you deploy the models. And the third part is integration. So once you have your machine learning service that tries to predict something or recommend products to users, how do you actually show that into the front end to users so that they can engage with it? And that's where the front end integration comes in. And you also want to be able to test whether your recommendations work. Are you actually able to increase engagement and increase revenue with machine learning compared to just, doing nothing? That's kind of where this multivariate testing and performance tracking comes into play. So just going back again, data. So with data, apps products, companies, services normally collect data related to demographic. So that means things like, I don't know, gender, age, location, what other thing did they collect? Device type. Yeah, so language, for example, these are demographic information. They also collect behavioral information. So everything that you do in the app gets recorded. So, okay, you click on this thing, you click on that thing, you close this pop-up. All those things are behavioral data and they collect that. And the third is transactions. If you're buying something, all of those transactions are recorded by the company. And then lastly, there are companies that provide data externally. So this might sound scary, but there are companies out there that scrape the internet for public data. So they can scrape sources like LinkedIn, GitHub, LinkedIn, GitHub, your Facebook public profile. They scrape all of that and they provide that to other companies for usage. So companies might know like what industry you work in or which school you graduated from. All these things can be bought by through a third-party provider. So these are some of the data sets that are used. And there are also companies that, for example, if you live at a certain postcode, they can try to describe the social demographic composition of the postcode. So they can tell which postcodes are rich and which postcodes are not rich, or like if it's a conservative postcode or a more progressive postcode. So there are companies that provide data for that. And then there are these are the user data collection methods. So I don't know if you know, but there are cookies. So I think you are all familiar with cookies being CS students. So cookies are just the small pieces of code that companies use to track you. And there are two types of cookies, right? There's first-party cookies, and then there's third-party. I think in the earlier years of the internet, the third-party cookies are very popular. Like they basically track you everywhere you go on the web. But now they're trying to phase out third-party cookies because of privacy reasons. And so more predominantly, first-party cookies are the norm. First-party cookies, when you go to a new website, they basically have this pop-up that says accept all cookies, right? And you try to accept or not accept. And this is what they use to know who you are and track how you use the app. So when the next time you log in, they would know that, oh, you've logged in before and this is what you did previously on the website. So that's used for data collection in terms of analytics. Obviously, they want to know how many users are browsing their app. But also they want to personalize the experience for you. So if you clicked on this particular article or click on this particular page before, then they might try and show that page to you when you come back to the app or the website, or show similar pages. So that's kind of how that whole third cookie data collection works. And there are SDKs for this. And then the other thing is customer relationship management tools. So systems like Salesforce, that is used to collect data from the user. Say, for example, when they sign up, that data gets stored in a CRM platform. And in relation to that whole data collection thing, there's consent and PII management. So companies can't just use your data without you consenting to it. It's illegal for them to just, you personalize something for you without you authorizing that. So that's where consent and PII management comes in. So if you say that you don't want to be, you want to opt out from being used as a training example or using your data to personalize experience for you, you can do that. I think in Europe, there's GDPR, and the US has an equivalent version of that as well. I just don't know in the Philippines. I'm not very up to date with how the whole legal framework around data collection works. And then there's user data consolidation. It's about trying to combine all of these different data sets that you acquire externally and data sets that you have internally and data sets provided by the user. You have to be able to merge that to get like a 360 view of the user and use that information to personalize. And in terms of infrastructure, obviously there's things like data storage. So you have to have a mechanism to store data. And in here, you need a data warehouse and a data lake or a data lake. So data warehouse basically has all the data from different sources into structured tables, so that it can be used for analytics purposes and it can be used for machine learning. So maybe the company or the app has different databases, and the data warehouse basically consolidates that. And data warehouse is more of like offline or batch use cases. It doesn't store real-time data. It stores data that's probably off by a few days, for example, but it's still useful because you can go in there and analyze usage patterns or get insights or build models based on that historical data. And then there's data lake. Data lake is very similar to data warehouse, but it's different because it can include unstructured data. So things like text data or images, these are all unstructured, and that's where the data lake comes into play. And then for compute, so there's different types of compute that you might need. So you might need compute for real-time data processing, and you might need compute for processing big data. Those are two very different things because real-time data processing is time sensitive, whereas big data processing is not, and it's often batch. And then you have compute for ML workloads. So those compute that you're using to train your models and serve your trained models as a service. And also, quick mention, standard in software engineering now, you have infrastructure for launching microservices, because your model will be a service amongst other services within the app. And so there has to be infrastructure to orchestrate those different services. And then obviously security. I'm not a big security girl, so I'm not gonna talk about security, but it's important. Yeah, so in machine learning, the machine learning bit, as I mentioned before, there's model development and then model deployment. So for model development, you can either do a custom built model, and that's basically what companies with data scientists do. They build their own models and try to deploy them in-house. But there's also services that offer machine learning as a service. So Amazon Web Services, or AWS, has these products. They have things like Amazon Personalize. I think they also have a product that does forecasting. I think Google might have equivalent services as well. There's also like ML as a service platforms like Data Robot. So these services, you don't need to have a data scientist or a machine learning expert in-house. You just give them the data and they train the model, and then you get a prediction out from them. So it kind of abstracts that whole process. You just give them input and they give you output. And the whole development of the model is like out of the picture. Some companies do that as well. Yeah, and in terms of deployment, there's two ways. So the most common way is for you to deploy the model as a service or as an API. So as I mentioned before, it becomes a service, and this model can be called on by other services to get a prediction. And that's what most companies do. But then others also just publish the output in a database. So you would like train a model, spit out a prediction, and then these predictions are just stored somewhere and it can be accessed later. So it's not real time, more like a batch sort of use case. Yeah, and in the integration is just how this model gets surfaced in the front end. And along with that, there's multivariate testing. So you would often hear people do A/B tests. So A/B test basically compares two types of experience for a user. So maybe one is personalized and the other is not. And you try to test which one works better. Or maybe it's two versions of personalization. Maybe this one uses one algorithm and the other uses another, and you see which one works best. And ultimately, the variant or that particular user interface that has maybe more engagement or more revenue becomes the winner. And you kind of evolve and iterate based off of that. And performance tracking is very important in that particular scenario. You need to be able to collect data on how the users are engaging with your personalized experience. So maybe that's collecting click information, like adding event tracking code, so that when they click on something, you know that they did that action, and you can account for that when you're tracking performance of your personalization algorithms. But yeah, let's put this very quickly in a practical scenario. So I have here an example, Lazada. I just took Lazada. It could be any e-commerce website, basically. assuming that we work for Lazada and we have this section in the homepage called Just for You. And currently, the Just for You section only shows popular products or products that are promoted by Lazada because companies pay Lazada and they would like to push their product up in the top so people can see them more. So at the moment, it's not personalized. Everyone gets the same thing. It's not a real Just for You because it's just for everyone, basically. And we want to know what we want to do here is we want to make this individual personalized to the user. So it's not the same for everyone. You want to provide a customized list of featured products in the homepage based on what the user has previously purchased or products that they've viewed before. That's also like one way of inferring what they might like because they click on this page and they view that product. Maybe they just haven't decided that they will purchase it, but in their mind they might want to purchase it later. So yeah, that's our task. Now, how will Lazada do this? So the first part is data. So Lazada will collect transactional data from a CRM system, CRM meaning customer relationship management, and that just records your transactions and some data about you. And usually they use SAP for that. There's a lot of CRM applications out there. I'm just citing like a common industry platform, and usually it's SAP. And then in the other thing that they might collect is clickstream data. So because you want to track which pages the user has viewed or products in the pages that the user has viewed, you want to collect clickstream data. And usually they use Adobe Experience for that. So all the users' clicks, interactions with the website gets recorded, and that all gets persisted in a data warehouse. And by the way, one thing I would like to point out here, this is in batch mode, meaning it's not real time. We are inferring products based on data based on big data. So it's batch, it's offline, meaning the recommendations don't change that often. Maybe they can change on a day-to-day basis depending on how you schedule your jobs, but they're not like real time, for example. So yeah, that's the data collection component. And the next part is machine learning. So maybe we can use a collaborative filtering algorithm to generate the recommendations. And the output of the model will be persisted in a data lake. And then the model that was trained gets served as well. So that gets served. At the moment, because this is batch, this will be just like a script or a Python application that loads the trained model and loads data from the warehouse and then generates a set of recommendations. And those recommendations will be persisted in a database. So what this would look like, maybe it will be like user IDs and then list of products per user ID, or it could be like product ID and then list of similar products, depending on how you try to structure your collaborative filtering problem. And then what happens after that is the integration. So you will have an API or a service that the front end component can call on. And this API, its only job is to take in user ID or product ID and then spit out the output of the machine learning that was persisted in the database. So say product A, you would then return, this API would return a list of products B, C, D, and that would be consumed by the front end, and that is what the user would see. So that's how you would try to integrate that in the front end. And then obviously there's the A/B testing part and the performance tracking. So you want to know how the user is engaging with the recommendations. Are the recommendations effective or not? And you know that because if the recommendation is effective, they will buy it or they will click on it. And you track that as well. And that data goes back to the warehouse. And you use that data to make dashboards and see whether your model is working or not. And yeah, that's it. Sorry, that was a pretty long, took longer than expected, but I'm now happy to take questions. Hope that made sense to you guys.
Yo, thank you, Miss Christine Bali. So in Miss Christine's discussion, we got to see how ML-based personalization is being used in a lot of real-world scenarios, like product recommendations, say, for example. She also gave us insights on what do we need to have set in our applications to enable these ML-based personalization. Specifically, data collection and consolidation, data infrastructures and analytics, machine learning models and development and deployment, and more. So we were also given a potential solution architecture for implementing a just for you recommendations feature. And with that, I believe we're now smarter and more informed than we were 13 minutes ago. So a lot of thanks, Miss Christine. So I guess for this, we will accept some. Oh, we actually have some questions already. So Macy, can you get the first question?
Okay. The first question over here, I think I'll take a simpler question first. Is for a news user, how are recommendations generated?
Oh, that's a very good question. So when working with recommendation systems, you have what we call cold start problem, where you have a new user or a new product, and because you don't have data on those things, like it's hard for the model to like recommend something. So what we do in those scenarios is, well, there are a couple of techniques, but I'll cite some that are commonly used. So one is if it's a new user and you know certain information about the user, like their locale, like where they live, their platform or device that they're using, their postcode, for example, you can try to just recommend what's popular with other users in that postcode. So that's kind of like the default that they would see. And that often works as a first recommendation. Over time, as this user continues to engage, then you learn more about them. And then that's when the usual algorithm recommendations would kick in. Yeah. Second thing is, if you usually when a new user signs up, you try to collect more data on them during their onboarding process. So you might ask like what they like. Like I think in Netflix they will ask you what movies you're interested in. Or I signed up to this app called Letterbox recently, and they will like pop up a questionnaire as to what movies you'd like. So there's this initial questionnaire phase, and that also can be used to give you recommendations. And if in the other scenario where it's a new product and you don't have anything yet on this product, like nobody has purchased it because it's new, you can also just try to find users that have purchased a product that is similar to this new product. So if it's like what is the iPhone number now? iPhone 14?
I don't know. They come out with so many.
So it's like iPhone 14, right? Maybe people who purchase iPhone 13 might be interested in purchasing iPhone 14. So that's kind of how we address that cold start problem in recommendations.
Thank you
That's
for that,
really,
Miss
really
Christine.
interesting. Because
Yeah,
like
that's really interesting.
it's so nice to see like it's nice and really interesting to see like how like machine learning and like recommendation algorithms are like weaved into our daily lives, and they make everything like a little bit more convenient for us, especially like in terms of like the content we watch and how efficient that finding of content is.
Yeah. But also in lieu with that, I guess we have a good question here. Are recommender systems susceptible to bias? Because whenever the anonymous sender watches some YouTube video with a little political content, he or she gets some recommendations for more politically extreme videos. So
Yeah. So there's an inherent bias baked in a lot of recommendation algorithms because again, machine learning works with patterns within general patterns detected in a big data set. So there's the popularity bias. So oftentimes popular products get recommended more. And second, there's that tendency for algorithms to keep recommending similar content to what you already have done before. So like there's nothing new. Like sometimes it can feel like this is the same stuff that I've watched before. I want something new. So there's that I guess frequency and recency bias is what I call it. Most people who build recommender systems have ways of addressing that. sometimes they would introduce like a parameter that controls novelty. So like I believe Spotify has this where like they would recommend music to you that based off what you already listen to, but then they would introduce something novel. There are different ways of generating that novelty. Maybe it's an artist that you haven't listened before, but your friends are also listening to, or it could be a totally random suggestion to just mix things up a little bit. Yeah, for popularity bias, I think they try to penalize, like when you're training the model, there's a factor at the end that tries to penalize popular products. So, and they also try to normalize it. So it's not absolute. They will like normalize based off the general popularity of the item. So you're not necessarily biasing most popular items when you're training the model. So there's algorithmic ways of doing that. And also there's just, systematic ways, I guess, like from a when you're rolling out the recommendations, maybe you can like have a filter list such that this user has been shown this item 5 times already, so they probably don't like this item. So there's a couple ways to address that, but those are just some on top of my head.
That's really interesting because as consumers, we don't really see the nuances behind on how these are really being architectured by the engineers. So
Okay, we're going to our next question, which is like kind of highly rated on like our Slido, which is, in your opinion, when does personalization cross ethical boundaries, if ever it does, and how can it be avoided?
Yeah, that is a very good question and a very valid concern. I think because I'm working on personalization, one thing that we always try to do is have an opt-out mechanism. So you always have to give the user an opportunity to say that I don't want personalization, and so they just get the generic experience. Another thing is whenever you have a change, whenever you try to use the data point that the user has given you into another use case that they have not consented before, you have to update your terms and conditions and have them opt in or opt out again. And some companies are very sneaky around that, like they don't make it as explicit, and so that's kind of like a corporate corporate value sort of thing. I think the second one is in terms of dealing with data that concerns minors or data that concerns medical information. These are really sensitive. I think in the US, there's legislation that doesn't allow you to use data on children below a certain age. And obviously for medical information, I think that is a very guarded like piece of data, because it can, if it gets leaked, right, it can be detrimental to the user's reputation and all that. So there's like legislative guidelines around it, and I think what you can do as a builder, as an app developer, is to try to be a good human and as like develop user trust and not break user trust by following legal guidelines, and also not using users' data when they haven't consented to it, or for nefarious purposes. I think that would be my answer to that. It is a very like rich topic, and it's like something that I'm still learning on as I go as a practitioner in this field. But those things that I've mentioned to you are just some of what I know so far.
Yeah, so like the I think the one you were mentioning about like the US legislation on kids, I think that's COPPA, right? Like the
Yeah.
Children's Online Privacy Protection Act. Yeah, it's
Yeah.
like, I think YouTube had like an issue a few years ago about collecting data from children. I think that so that's a pretty direct thing of like machine learning and like the ethical considerations that people have to make when that happens. So yeah, Josh, let's move to another question from the slide.
all right, let's digress to a more general question. I think this comes from someone who would want to work in the field someday. So what would a tech stack for these applications usually look like?
Yeah. That's a very good question as well. So I kind of mentioned that a little bit earlier. So I probably start with the data. So personally, in the companies that I work for, it's usually Snowflake, where that serves as our data warehouse. So all of our modeling, data exploration happens in Snowflake. There are like Amazon AWS equivalent and Google Cloud equivalent to that. I think Redshift is the Amazon equivalent. So yeah, but I think from what I've experienced so far, Snowflake data warehouse, and then for exploration or modeling, you probably use SageMaker, AWS SageMaker. You are able to spin notebooks there, and you can do data exploration as you would in like a regular Jupyter notebook. But then the nice thing about AWS SageMaker is you can easily deploy your model as an endpoint. So you don't have to worry about like creating your own Flask application, writing your custom Flask application in order to deploy this model that you have. They have an API that allows you to just deploy instantly. And then, so the infrastructure part, like building containers and deploying these containers, like you don't have to worry about that within AWS SageMaker. Obviously, some companies do a mixture where like, okay, maybe the development happens in their own custom Kubernetes clusters, but then like the deployment of the model happens in SageMaker. So it can be a combination. And then, yeah, so like, I think that's this deployment and development part. What other modes have I seen? And like, as I mentioned before, the machine learning model becomes a service. So like it can be integrated to like other services, maybe like a Node.js application or like, I don't know. I am not a front-end developer, but it's an API, so anybody can call it. Yeah.
All right. So I guess that those are really good information for whoever asked this question. So yeah, if you ask this question, get ready for a journey that you will have in the field someday.
I think we have time for one last question. The last question we have here is like, do you have recommendations for free data gathering infrastructure options to implement ML personalization with?
That's a good question. I have not actually personally tried to like spin up my own like app and like incorporate data collection software in it. But maybe you can get like a free tier of Adobe Experience or Google Analytics. There was one app before that I forgot the name of. 1 second. But we were using this app to like as an alternative to Adobe Experience. So let me just do a quick Google. Because we were using this in my previous job before, but I just forgot what it's called. Anyway, you can Google alternative to Google Adobe Experience. I think one is Optimizely, based on my quick Google search. But that's not the one that I wanted. I just forgot. Yeah, just Google it. There'll be a bunch of them, and maybe you just try like a free tier of that, and then you can get a flavor of how this data collection using cookies work for a particular app.
Oh, that's really interesting. That's like there's free options for everything, and you can kind of dip your toes into trying to figure out like how like personalization works. Okay, I think that's all the time we have for our open forum.
All right. I guess this first destination has set us to a good starting track.
So as a token of our gratitude, we would like to give our speaker this certificate of appreciation.
And the certificate reads Certificate of Appreciation, the Association for Computing Association for Computing Machinery, UP Diliman Student Chapter Incorporated. It awards the Certificate of Appreciation to Christine Balini for being an esteemed speaker at UP ACM Fest 2022 destinations held on July 23rd to 2022.
So thank you so much for imparting your knowledge and really talking to us about like how this like machine learning personalization works.
Yes.
Awesome. Thank you so much for this opportunity. I hope you learn a bit from that.
So we're just going to have like a quick photo for our event. So then I think our logistics team's gonna have one. There you go. Photo op. Really quickly. Okay. 1, 2, 3. Okay. Can I confirm from our lodge team if that photo was taken? Okay. So we have one. There you go. So before we move on to like that part, so we're going to we're just basically doing something really quick to appreciate everyone for attending this lecture and coming along with us for our different destinations. So for the people, for the attendees, we're going to be having a special raffle draw every after lecture to basically reward everyone for like sitting through and actually learning. So it's a little incentive for you guys. So yeah, so it's going to be a raffle of 500 pesos for a random attendee, every speaker. So the winner for the first draw, the winner for the first draw of our raffle, it's not on screen, I'm just gonna announce it, is Arnel Vincent de Guzman. Congratulations. So
Congratulations.
someone will be PMing you on Zoom to coordinate and for you to get your prize. So we just want to kind of remind everyone here that if you haven't already, you can register for like you can go and add your name to our registration so you can have we're going to be having more talks later. You can submit your resumes there if you want them to be submitted to our sponsors. We can all then if you also register, then it will be easier for us to contact you if you do win a raffle prize. So yeah, congratulations. We'll be having more later.
All right, I guess that's it for now, and I think this is the best time for us to have to take a small break before we travel to our next destination.
Yeah, have a quick water break, refill your snacks, answer the call of nature, or just take a breather as we show you our lovely sponsors and partners who made this event possible.
This program will be returning by 2:30 p.m.
We continuously improve. We innovate.
We create space for creativity. And we're not just colleagues, we're a collective here.
This is what we love doing. Because ideas can change the world.
It's very hard for you to provide for your family. Freelancer has helped me to overcome all that.
My life dream is to go to Japan. Thanks to my freelancer.com incomes, I have been able to save enough money to make this dream a reality.
Thanks freelancer.com for this wonderful idea to pull out the creative stage from the shell in front of the world.
Hi, I'm Greg.
Hello, I'm Jean.
Hi, I'm Justin.
And this is an example of
The day in my life as a software engineer
at Expodoc.
Wake up.
I'm getting ready for my stand-up meeting now.
Morning stand-up.
Alright, let's do some work today, guys. Go team. Yeah.
Work.
It's currently 9:30 a.m. I'm checking my calendar right now for my meetings, going through my emails, checking my Slack, also having some breakfast.
Figure out how the heck to do my task.
I'm done with all my morning meetings, so now I'm gonna go back to fixing my draft PR. Hopefully it'll be up soon.
Team building.
It's 12:30 in the afternoon, so I'm gonna head out for lunch.
Super mega ultra power coding. Have lunch and pet dog.
So I just finished lunch and I got my caffeine for the day.
Stir, stir, stir. Bugs. Back to work.
Oh my god, it works.
Great. Success.
So it's almost 5 and I'm getting ready for my second stand-up of the day. And after this meeting, I'll probably wrap up and be done for the day.
Play some TFTLMAO.
Education matters to us as much as it matters to you. We know that in teaching students, we make sure that they're one step closer to their dreams. With Course Hero, you can be a part of a growing community of passionate educators who are willing to help students learn. Our online learning platform gives you the opportunity to provide explanations to student questions and to share study resources for specific courses. Think of it this way: when you explain, you gain. So, what are you waiting for? Be a tutor now.
Education. It starts for all of us with a blank piece of paper. And then it leads to knowledge, curiosity, and discovery. Worlds open. Minds expand. But the road gets more challenging. And no matter how brilliant we may be, at some point, we all get stuck. So Course Hero did something about it. We set out to get students unstuck. And we made it our mission to help more people graduate confident and prepared than ever before. Today, Course Hero can help students with virtually any course at any college, anywhere in the world. And we're leveling the playing field for all, from students with children, to students with jobs, to students who are just plain in over their head. But we still have a long way to go. Creating a world where every student graduates is an incredibly rewarding but incredibly massive challenge. It requires finding the world's best problem solvers. It's engineers building the world's largest educational content marketplace. It's AI specialists building personalized learning and teaching tools. And it's designers and marketers who share a passion for what we do. We're also a great place to work, and it goes beyond ping pong tables. Walk through our doors, and you can actually feel the collaboration and energy. We are Course Hero. We are a hyper-growth company that is changing the way students learn and making a meaningful impact all over the world. Help invent the future of student learning.
Hey there! Looking for a no-hassle side hustle? I'm here to introduce you to a text-based Q&A platform where you can earn by tutoring whenever and wherever you want. Welcome to Course Hero. Course Hero is an online learning platform of course-specific study resources. It's a platform for students around the globe to get 24/7 homework help. As a text-based tutor on Course Hero, you can help students learn by writing step-by-step solutions or answers to student questions within your specialized field on the platform. You can choose your subject expertise, from computer science to engineering, science to math, and everything in between. As a tutor, you can answer questions in your subject expertise and help over 10 million students. It's up to you to decide whether you want to go for regular or more complex questions. No need to worry about compensation, as you'll be paid per question answered instead of per hour. Enjoy the flexibility and freedom to be a tutor on Course Hero whenever and wherever you like. So, you might be asking, how much can you expect? The base rate for questions is $3. But for more difficult questions, there are complexity bonuses. Top-tier tutors can earn around $1,500 per month. Ready to be a tutor? Here are the things you need to know to get started. You must be fluent in written English, and at least a college student with educational
Alright. Yo, Macy, knock knock.
Who's there?
Tank,
Thank you.
you're welcome. And now we're back.
Ah!
Get cozy and warm as we're right on our way towards our next destination. Now let's re-embark on our journey to our next speaker.
Okay, so our next speaker is currently working as a software engineer and a full stack developer for White Widget. His work currently focuses on developing decentralized chat technology where communication is relayed peer to peer rather than through a central server.
His work is also currently involved in knowledge engineering, which is a field that aims to develop artificial intelligence that emulates the judgment of experts in a given field.
Let's all welcome today's second guide on the topic of knowledge engineering, Mr. Jewel Joseph Arroyo. Hello.
Hello, everyone. Can you hear me?
Yes, we can.
Yeah. I think we should just jump straight into it since there's a lot to discuss. Yeah.
Yeah, you can start sharing your screen.
Is it all good now? Or
Yeah, we can see it.
okay. So I'll be talking about knowledge engineering. So first of all, what is knowledge engineering? So in a sentence, it's just we want to make machines understand things the way we do. So specifically, some expert in a field, because we want to be able to reason about without them, basically. So yeah, so we want machines to be able to make decisions that experts would be able to. And of course, one key thing about it, offloading that work to machines, is that we don't need experts around, which makes knowledge more accessible because everyone can just go on the internet, let's say, and access the same knowledge that the expert would have. So yeah, this screenshot on the right is from Google. So it was able to deduce which parts of a Wikipedia article would answer our question. So and also which other search terms are relevant to what we searched for. So that's something that might be answered by going into knowledge engineering. So here we have this pyramid of, so we want to answer what we mean by knowledge. So at the bottom, we have all our data, and we have a lot of data from multiple sources, and most of them don't really have any apparent meaning to a common person. And then next stage will be information. So that's when we process our data and turn them into stuff that can answer basic questions. So stuff like what, or when, where, how. So all of those questions, like say you would type on Google, like, who is this person? When was this person born? So that's when data becomes information. So we read out all the stuff that we don't need, and we sort of get all of the data that can answer questions. But of course, the next stage will be knowledge. So all of the what, when, where, and how, and why, it's not really enough to make meaningful decisions. So it's sort of just, you can think about it as just key value pairs. So knowledge is when we bring all those things together to, say, answer more difficult questions, more practical questions. So you can think about it as, say, a thesis statement when you're doing your thesis. So knowledge is what you need to do your thesis. So it's not just information and it's not just data, but of course you need both of those. But you can't just use information to write a thesis, because that's just homework, basically. And then wisdom is when we can start asking bigger questions that maybe not even the experts in a field would find easy to answer. So maybe stuff like which export would have the most economical impact if it goes down, I guess. So that's an example. So all of these very difficult questions can be broken down into simpler questions, and all of that can be eventually done by machines, which means we don't need experts anymore. We can just, of course, we'll need them at the start to model all of that knowledge, but then we can make the correct decisions more accessible to everyone. So why do we do this? We already have a massive amount of data that come from multiple sources. So one problem is, how do we find out which data will be meaningful? And another is, how do we connect all of the data from multiple sources? Because a lot of the data that we have don't really, may not necessarily relate to each other, but conceptually, they might be related. So how do we solve that problem of being able to use different sources together? And of course, we want to gain insight into our own data. So this is where the knowledge part comes in. So we want to be able to answer questions. And of course, we want to present this to others without them needing to go through all of the research that we've done beforehand, all of the investigation that we've done beforehand. So we want them to be able to easily access our conclusions and then confirm our conclusions, or maybe challenge our conclusions based on the evidence that we uncover. And of course, we want our machines to be able to do all of this. So there's that engineering component as well. So why do we do it? We want to answer difficult questions. We want to, quote unquote, generate meaning, because computers can make inferences for us. And we want computers to be able to reason autonomously. Let's get to the engineering part. So there's basically, I've outlined 4 important steps on how to go about this goal. Whoops. Making machines reason like we do. So we want to be able to first capture what it means to mean, so to speak. We want to capture meaning and put that into a computer. So how do we do that? And second is we want to generate inferences. So we don't want to keep restating the obvious. We want to be able to build on existing knowledge and make conclusions from that. So we want to keep adding and be able to draw those connections programmatically. So the third will be to surface connections. So this is basically what research is for. We want to surface connections that are not immediately apparent to the public. Like, say, do vertical stripes make you look heavier, or do horizontal stripes, blah, blah, blah. So it may not be apparent. So we want to do research on that. But again, the thing is, we already have a lot of data available publicly and even privately for enterprises. And the only missing thing is, how do we go about doing research on them? Using them for research. So if we're able to model the way we reason about data, then we can have machines do that for us. And also we can make that more apparent for others who may not be experts. And of course, ultimately, we want to solve complex problems. So we'll get more into that later. So first off, we want to capture meaning. So let's have a look at this. So this is just Lego. Well, technically, it's just light hitting your eye. But it's just Lego. But most of us, I hope this is not too old for you guys. Most of us know what these Lego figures stand for. So it's actually The Simpsons. So it's all just blocks of Lego, but we know that it's The Simpsons, and that requires some knowledge to know beforehand. So yeah, we understand using clues, that's what we call contextual knowledge. We need a lot of context to draw conclusions from a limited amount of data. So say here, how do we know that that those 4 blue blocks on top of the second figure is actually hair? Like they're all just Lego. So, and how do we know the red block is a shirt? So all of these things require a lot of context on what is hair, what is the Simpsons, and who are they, blah, blah, blah. So let's have a look at this magnificent painting by Caravaggio. This is the Calling of Saint Matthew. So when we look at the painting, immediately we understand what it's, on some level, what it's trying to show us. So although it's really just light hitting your eye, like I mentioned, so when we look at the painting, we don't just say light has hit our eye. That's not what we think about. We use clues like contrast, brightness, and saturation to infer shapes. And then shapes become things like, say, a person, a hat, a table, a window, blah, blah, blah. And then when we understand what those things are that constitute the painting, then we can use that to infer some sort of message. And that's where that's where knowledge engineering can come in. So how do we understand what that message is? But again, this is all just paint. So which is really most of the web is just plain data. Although we're making an effort to make the data understand that it's not just paint, that it's actually shapes, that's actually things, and there's actually a message behind it. So I think that effort will be what we call this semantic web. So we'll not be covering that, but let's keep going. So yeah, the idea will be we want data to be things and not just strings. So in this case, the painting, we want the painting to be figures and not just paint. So if we think of this, if you show this to a person and they don't know anything about the real world, say an alien, maybe not a person, and they don't know anything about the real world, they would probably just say, "Oh, is that some sort of substance that you've painted? I guess you've painted over a wall or whatever." So yeah, we want to be able to see data as things and not just strings. So that tagline is from, I think, the Google Knowledge Graph. So let's have a look at this tweet. It says Jay Cutler passed his physical and is officially a dolphin. So it's funny out of context, and maybe a computer won't be able to understand what that means specifically. So what does it mean to be a dolphin? Like, can people become dolphins? And what is a physical? So stuff like that needs a lot of context to be able to understand. So I don't know if everyone here can immediately understand what the tweet means, but let's unpack that. So again, how can we help a machine look for clues? Well, we can model our expectations about certain things. So say a person, a figure of a person will have a head, usually. There could be headless statues, and that still represents a person. So we can model some expectations about things and then hope that the machine will be able to deduce what we mean based on some expectations that are met. So that's where we get into domain ontology. So how do we tell a computer what a thing is? When we ask what something is, we want some sort of definition, but that's not very easy to grasp for a computer. Well, most definitions, in theory, it's very hard to define something, but that's not our goal when we want to model knowledge. We just want to say enough about a thing so that it can't be confused for something else. So that's all the computer needs from us. So say, for instance, this tweet again. So one thing we might ask is, what is a Jay Cutler? So apparently there's a bodybuilder named Jay Cutler, thanks to Google. It could be a bird that makes cutlery. So it's a jay who's also a cutler, which is probably unlikely. But we don't know. It could also be the American footballer, Jay Cutler. And another question we might have is, what is a physical? We know that it can be ascribed to some Jay Cutler, and it's something that can be passed. And of course, what is a dolphin? It's something that a Jay Cutler can officially be. So these are all, I've outlined all of these possible relationships between the concepts within this tweet. So depending on which relationships we find to be quote unquote valid, we can draw some conclusions about what each part of this sentence is. So say, what is a Jay Cutler? So let's try to use some relationships between objects to try to pin down what this is. So we can use a dictionary, which is just data. So we know that cutler is an occupation. So maybe you have some sort of key value store that says cutler is an occupation. And we also know that Jay is a bird. So we want to ask, is there such a thing as a Jay Cutler? So is there some relationship between a bird and an occupation that we don't know about? Well, we as people probably would not think that there's such a relationship. So, but of course, we're quote unquote experts on the real world compared to machines. So how do we model that sort of knowledge? So we know it's people that tend to have occupations such as a cutler. So it's probably not a bird that's a cutler. That's probably not what Jay Cutler is. So, but we know that Jay Cutler could be a bodybuilder, or he could be an American footballer, which is data that we already have. So we have some evidence to suggest that maybe Jay Cutler is a person. And we know that a footballer is a valid occupation for a person and bodybuilder as well. So maybe Jay Cutler is a person. So now we want to answer, what is a physical? Again, we're going to use object relationships for this. So like we mentioned, a physical is something that can be passed. So Jay Cutler passed his physical. So what is a physical? Something that can be passed. So many things can be passed. It could be a law. You can pass a law. You can pass a body of water, like a vessel can pass through a strait. You can pass on a duty to someone else. And you can pass judgment, I guess. So there's two senses of the word pass here, which is it could be the result to pass something. So I passed a test. A law was passed. Or it could be some other transitive verb, such as passing a duty on to someone else. So as we can see here, it could be something, a physical could be something that has a past result, or a physical could be something that's passed on to something else. So how do we find out that it's actually a physical exam? So we think that Jay Cutler could be a person. So we have some previous evidence on that, although we're not so sure yet. And we also know that Jay Cutler is not passing the physical to some other object. So if we go back to that sentence, passed his physical to, it's not there. It's just past his physical. So we know that it's not related to some other object of the transitive verb. So it's likely that it could be an exam, because exams we know have pass or fail results. So that's something that we can use to as a clue to deduce that Jay Cutler passed a physical exam. Well, not physical, but we know it's an exam. And we also know that there's a subtype of an exam called a physical exam. So that's something that we need to model, because that's how we think of it when we're trying to to parse the tweet. We see it as a physical could be an exam, I guess, because um, you can pass an exam, and also we might know beforehand as people that there's such a thing as a physical exam, and then we make that connection. Oh, he passed the physical exam. So there you go. Okay, so we still don't know what the dolphin is unless you're an avid sports fan. You probably don't know what a dolphin is, but you can probably deduce it. But how exactly are we deducing it without knowing much about sports? So let's gather more clues. So here we know that it was tweeted by someone, and we can see that this someone is an NFL reporter and also a host and all the other stuff that you put there. So we can use this data from Twitter. Well, we as people can sort of investigate further on who this person is to try to understand what this tweet is about. So we see that he's an NFL reporter. So that must mean he talks about the NFL, which is a league for American football. So this Jay Cutler is probably the American footballer. So this is how we go about reasoning based on knowledge that we already have. We can find out what something else, something novel means. So maybe you can also gather some other sources, like maybe we know that NFL has a Miami Dolphins team, and you can call those team members Dolphins. And maybe you know that you need to pass a physical examination to be an official member of said team. So this is all contextual knowledge that will uncover the meaning of something novel. So if you know all of these beforehand and you're constantly immersed in all of this information, all of this knowledge, you're knowledgeable about sports, then you would be able to find out what the tweet means in half a second. So imagine if the entire web would just look like this. So it immediately tells us what it means. So American footballer succeeds in a medical exam and is now a member of the Miami Dolphins. So that's ultimately the goal of domain ontology. You want to disambiguate and draw relationships between objects. So the machine can use them as clues. So yeah, we have all of this information, and as humans, we know how to bring all of it together. But we need to be able to tell machines how to do that as well. So if you remember, the way we did that was identifying relationships between objects. Like we know that birds can't have occupations, and that it's people that have occupations. We know that things that can be passed could be a test, it could be a bill, blah, blah, blah. So the more we define relationships between objects, the more we can pin down what exactly something means. So when we describe more relationships, our concepts become more defined. So say if you have no definition of, say, an exam, but you have the definition of a bill, then you might think that Jay Cutler's physical is a bill that was passed. But then, of course, you want to make that relationship more descriptive. So maybe you say that, no, only government organizations can pass bills or something. So that's when you draw that additional relationship, then you have more evidence to suggest that it's not a bill, it's probably something else that was passed. So how can we teach a machine? So we just basically tell a machine all of the facts that we know, such as bird has no occupation, so we don't write that down. Person has an occupation of class occupation. So stuff like that, that the computer needs to know to be able to draw conclusions. So we'll get into that a bit more later. So basically everything we can communicate through language can be a triple. I'm not a linguist, but I'm pretty sure that's 99% true. um, so, say for instance, we want to say that the Miami Dolphins competes in the NFL. Then we have the subject Miami Dolphins, the predicate competes in, and the object is NFL. So let's just go through this. So we can have more complex sentences like an NFL team membership requires the candidate to pass a physical exam. So how do we model something like that? We can have multiple multiple facts. So we can say NFL team admits NFL candidate. NFL candidate must have credential passing physical exam. And the passing physical exam has a pass result. But of course, when we're starting from scratch, the computer doesn't know what any of these things are. We can maybe have more relationships, which are listed there. So say physical exam is taken by a person, and the inverse property of taken by is as credential. So when something is taken by someone has the credential of that something like that. So we can draw more relationships. And this is a standard that we're seeing today, the resource description framework, the RDF standard for writing down all of these triples. So since it's standard, we can have machines understand what we mean when we write down all of these facts. So, which is of course useful for generating inferences. So the thing is, we don't want to write down all of the facts. We want to write down just a couple of facts, and then the computer will understand using all of the facts that it already has to infer other facts that we didn't explicitly state. So some implicit connections. So yeah, if we describe how facts are related, if we can somehow document that, which we have using triples, then machines can make the inferences for us. So it's RDF is a standard and it's a formal language. So actually, what I've written here is just pseudocode technically, but it retains the same format of subject, predicate, object, which is really the essence of the RDF format. So we say that Jay Cutler is an NFL candidate, and we say that NFL team admits. No. So we know, the computer knows that the NFL team admits Jay Cutler, and the reason for that is the computer already knows the fact that NFL team admits an NFL candidate, which we may have told the machine at some point in the past. So it can create this new connection of NFL team admits Jay Cutler. So it's a really easy way to go about it, to go about building knowledge. You just keep writing down facts. And if you probably want to reuse some existing concepts that you've already described to the computer so that it knows how to make inferences and to reason about the new fact that you've added. So say, for instance, this one, by saying that Jay Cutler plays for the Miami Dolphins, the machine can infer 4 other things based on stuff that we've already put in. So maybe at some point in time, we've added that Miami is part of Florida. We say that American football is the sport of the NFL, blah, blah, blah. So by just adding Jay Cutler plays for the Miami Dolphins, it can infer all of these other facts. So again, it can only infer these if we know what to ask. So we'll get more into that later. So we can also have subclasses and subproperties to help inferences. So let's say Jay Cutler is an NFL candidate, and NFL candidate is a subclass of person. Then we know for sure that Jay Cutler is a person. And let's say Jay Cutler passes a physical exam, and when you pass something, it implies that you also take the exam. Otherwise, you wouldn't be able to pass it. So we describe that as a subproperty relationship. So here the computer can deduce that Jay Cutler took the physical exam at some point because he was able to pass it. So there's also some other useful properties that we can annotate. So let's say the inverse of relationship is something that it's something that we have as a standard in yeah, it's something that we have as a standard, as well as the equivalence, symmetry, and also transitivity. So we can have all of these connections as well. So let's say when you have a parent, that parent has a child, and also when someone is a sibling of another person, then it's also symmetric, like that person is a sibling of yours. So and of course transitivity. So when something is inside something, and inside that is another something, then it's all like it that maybe let's use a concrete example. So as country has a city, and a city has a barangay, then a barangay is in that country. So yeah, we also have all of these, and these are all standard. You can just build on the work of others. So there we go. So we have the RDFS standard. Well, you can think of it as libraries, I guess, that you can import, so to speak. So there's an existing definition of a label, so you can label something, and machines know, since they also use RDFS. They know that you mean this is the label for that thing, and so on. So there are all other standards there. So since they're publicly available and they're in use by a lot of other knowledge engineers, then you can understand each other. But of course, using this equivalent to relationship, you can just connect what you have, what you built on your own, to what someone else built. So you can say that you also have a person. You've also created this person property. I mean, this person class. Then you can say, oh, when I say person, I also mean the FOAF. What FOAF means about this same person. So you can say FOAF person is equivalent to my person. So you can just string multiple sources of knowledge together. So how do we know what to ask? So this is really the technical part of this talk. So in which state, say, does every sports person we know of play for? So we have to run through all of the relationships between sports person until we arrive at a state. So here we say we want to select the name and the state, and we know that the person works for us, is a sports person. We want it to be a sports person. And we want the person's full name, and the person plays for a sports team, and the team has to be based in some place, and that place is under some state, and that's the state that we want, and that has to be a state. So it's sort of just stringing together all of the facts. We need to tell the computer how to traverse these facts in order for us to answer the questions that we want to answer. So actually we can try it out. So let's say we want to get the state of sports person. I'm going to put this in, hopefully it works. Yeah, so as you can see, this is from Wikidata. So they have a lot of data, and we can take advantage of that. We can query their data. So this relationship, this predicate, is being a member of a sports team. And then this is a home venue. So if you want to get a sports person's state, we actually have to course it through the home venue of their team, because sports people are not based in states, apparently, according to Wikidata. So we can just go through all of these relationships between objects to arrive at what we want and connect the two entities together. So let's just run that. So there we go. So we have Mark, Andre, Gragnani, whatever. plays for North Carolina, and blah blah blah. I've only queried for 10 because it takes a while to get all of this. It's a massive data store. So there we go. And again, we had the question kanina, which now we can answer using Wikidata. So what are all the possible relationships between a bird and an occupation? Is there really such a relationship? So we can try that out here. So here we see that we want a bird. That's basically the first thing, the first statement. And we also want an occupation. So this is sort of a variable. You can think of it as a variable. Like this means occupation. So there we go. It has to be a profession. Sorry. And this relationship has to connect bird and occupation. And then we select relationship. So here we go. We select relationship here. Label is just some magic by Wikidata using this, which is this line. Sorry. So let's. Okay. Apparently, there's no connection between a bird and an occupation. We don't have existing predicates. Well, as far as Wikidata is concerned, there are no existing predicates that connect the subject bird and the object occupation. So maybe we have some confidence that there's no such thing. And then, however, let's try this other query. So this is connecting persons to occupations. So this person variable must be a person. So that's the Wikidata person entity. By the way, you can just go on Wikidata and try to find all of these IDs by using their search function. And we want a relationship between a person and occupation. And as you can see, there's a couple. So it can be a position held. It can be an occupation. So ultimately, since we have all of this data and all of these relationships between entities, we can surface some connections that maybe are not apparent to people, which is what research is. We want to surface connections because that's how we add to knowledge. So let's say just this very trivial question: which US-based sports persons have founded a record label? So I don't know how you're going to do that with just Wikipedia, but luckily there's Wikidata. So let's just go through all of the sports persons that have a record label. So this is what we're looking at. I hope this is record label. Yeah. So has to be a record label. Let's just change that comment there. So we want this same sports person to be the founder of a company, and we want that company to be a record label. So let's run this. And you can see apparently some Rick Ross from Georgia founded Maybach Music Group, and some Master P, apparently an athlete, started No Limit Records. So these are all of the connections that we can surface. And if you can imagine, if we can make our connections richer and our data more, if we can add more data, then we can surface more concealed connections and answer more difficult questions. So sorry, let's just go through this. So yeah, so I don't know why that's cut off. So we can ask harder questions. So which politicians engage in tax fraud? So what single export does the nation need to control to gain enough political leverage over its neighbor? And what is the single most impactful measure, blah, blah, blah. And of course, how can we identify fake news? So maybe you can identify that by checking some fact against multiple sources that we can bring together and check where those sources are coming from. Who are they funded by? So you can add that to you can add that statement to your query. Like we want to know if this piece of information is independently verified. So those are all of the questions that are relevant to today that we can probably answer. And hopefully others can answer in without expert knowledge. So yeah, this is an example of a project by, I think this is called Follow the Money. So FTM for short. So their goal was to uncovering out which, I think that was the first question, which politicians um, are engaged in money laundering and tax fraud. So as you can see, these are all of the connections that they've built, which is where their data will fit into. So maybe they have a list of all the contracts, and then they can assign that to this contract class as instances of this contract class. And then suddenly all of these other inferences can be made by just adding one piece of data. So that's how we can solve complex problems. We want to break it down and make it simple to just keep adding and forget about the big picture for a minute, because the computer will do that for us. So yeah, so if machines can uncover evidence, then we can make hard questions easier to answer. And of course, if we document the way we reason, so if we make all of those object relationships public, then we can make knowledge accessible without the need for expertise. So yeah, and if you're interested in all of these challenges, these are actual questions that we ask in White Widget. So if you're interested in all of these, then we're happy to for you to join us. So that's it. I think we're ready for Q&A. Hello?
Yeah, thank you so much for the talk and how basically like computers process words, because like we understand like it's an inherent like human thing to be able to just understand words and understand sentences, but we don't really know like the steps that it takes a person to kind of deconstruct words for a machine to understand. So it's actually really, really interesting. Joshi, yeah. What do we have our first question here?
All right, I guess. Okay, I guess let's use this question to break off the ice. Hi, Sir Jewel. One question here goes: what are real life situations where knowledge engineering is used? Aside from the discussion, maybe.
So yeah, so one real life application is, say, it's actually been used to control the COVID-19 pandemic. So again, knowledge engineering is all about data and making decisions. So if we can document how an expert would reason about certain facts, then we can have machines do that for us. So currently we are working on we can work on uncovering political dynasties, for example, because those are all defined by relationships between entities, such as a politician is actually connected to this other politician, and yung levels of consanguinity nila. So I don't know the exact law, sorry. But again, I'm not an expert, but we can have machines be an expert and answer those hard questions for us and make that evidence apparent for everyone. So it's also used in, say, tagging news articles. If we know what an article is talking about semantically, so what is it talking about other than just strings? Again, we want things. We can suggest, say, other articles that are related to that, and of course, we can just use some statistical process to find out what are the related articles. But if we can use knowledge engineering to make those connections more meaningful, then maybe we can draw other conclusions, like this article is actually important to this developing story and whatnot. So it's also being used by, I think BBC is using a knowledge graph. So they're using an ontology to domain ontology to connect all of their stories, which they have massive amounts of. So that's one application.
I guess it's really interesting because before this, I guess personally I didn't know about knowledge engineering, but now I guess it's like it's a really helpful tool in giving more nuance to like connections that we already know and uncovering more connections that we don't even know of.
Yeah, exactly.
Oh,
All right,
okay.
Macy.
So another question here is how is the accuracy and efficiency of the model using knowledge engineering tested, specifically when it comes to decision making?
Oh yeah. So again, if you want to be able, the goal again is for it to be able to reason like an expert in that field. So, how would you test the competency of a knowledge graph? So obviously you would need an expert to confirm it. So usually when you start a knowledge engineering project, you will have some set of competency questions, which are questions that you want your data to be able to answer. You want your model to be able to answer. And if it can't answer those questions, then clearly you need to go back to the drawing board and try to draw out more connections, try to check all of the facts that you've described. Maybe you're missing something. Like say kanina with uh Jay Cutler, what if you don't know anything about the NFL? The model doesn't know anything about the NFL. So it can't make some conclusions about football. So that means that you have to revisit your model. And you can only do that if you have prior knowledge as an engineer about the NFL. So you can actually work closely with experts or you can be an expert yourself to help improve your models to answer and make better decisions.
Okay. Yeah, that's like so you have to have like someone who knows the topic look over it so that you can kind of replicate how the person who knows about it thinks about the topic, right?
Yes, exactly. It's a big project. Like uh, uh it's not gonna be some garage project lang that you can do on your laptop over one night. It's really an enterprise project, and the entire world is working towards building meaningful content that we can connect with each other.
So it's like a really big like worldwide project and then we're all working towards kind of being able to consolidate a lot
Yeah.
of data to be able to do that. So that's really cool. So we move okay, so our
Right.
next question here, Josh, you wanna read?
Yeah. I guess to your knowledge, sir, which machine model or program that uses knowledge engineering has the highest accuracy rating so far? Like, what's the most used in the industry?
Uh, I think we're thinking about this the wrong way if we're using words like accuracy. Um, what knowledge engineering is about inferring logic. So everything, technically in theory, um, is correct. So since everything you tell the computer, it considers a fact, then everything else that it draws will be a fact. So this is not about so this is all about surfacing connections. Yeah. You don't want to. You're not really concerned about accuracy. You're concerned about possibility. So, what are the connections that can be surfaced using your data? Like again, let's say political dynasties. You can't uncover that if your data is not correct to begin with. All the machine knows is everything you tell me about all of these politicians, I accept as true, and I will tell you who is violating the. Do we even have one? I don't know. Who? Yeah, who I get you. I forgot the exact law, but who is violating the political uh, dynasty law? Yeah, but I think no.
So it's not necessarily like accuracy, it's more of logic of like whatever you
Exactly,
feed
exactly.
it just connects. Ooh.
So yeah, it's more of investigative. It's not about collecting data. We already have collected data, and we want to be able to investigate connections.
Thank you for that. We're gonna move on to our next question, which is, are there any online and relatively easy to use tools, technology, and data sources to create / implement our vision of AI that can interpret arbitrary statements?
Oh, mm, I don't really work on with. The way I understand these questions is you want to be able to parse some text and turn it into meaningful concepts. Um, Actually, that's a very good question because I have this open, so you can just. This is Onto Text. Onto Text has a lot of tools for this kind of work. So maybe you can check that out. So let's just type what we analyzed kanina. Fast is physical and is now officially a dolphin. So yeah, as you can see, it identified correctly that Jay Cutler is a footballer, but it doesn't know what a dolphin is. It thinks it's the mammal dolphin. So there's still a lot of work to be done, but definitely there are tools available online. Typically, you would only need some way to store a graph database. I think GraphDB would be your best option for that. It also has built-in tools for knowledge engineering as well. So that's where you store all of your triples, all the facts that you want the computer to know. So yeah, you can try that out. That's tag.ontotext.com. So that's one example.
All right. I guess this will be our last question for your Q&A, sir. And then the question goes, what do you think about is this Lambda, the AI researcher that claims to be sentient? Or do you think it's the best we've gotten with knowledge engineering, or can we do better?
Well, really, our goal is not. Well, my goal is not to achieve machine sentience. Like that's not our goal. I think our goal is to make our lives easier. That's really what it all boils down to. I don't think we can ever. I think that's a philosophical question now. Like, if we come close to what knowledge is, we don't even know what knowledge really is. Like, what I said on my other slide thing, like we try to approximate definitions of things, of concepts. All we have are clues, and we can't really we don't even know what knowledge is. So how can we tell if we're getting close to something that resembles knowledge? We don't even understand the mind yet. So I think we have a long way to go even in neuroscience first before we try to use words like sentience for software engineering. So I don't think it really matters right now, is what I'm saying.
Okay. Yeah. I guess what's important right now is uncovering more of the connections that knowledge engineering may offer to us in the current status quo. And I guess if we use knowledge engineering properly, it will be a really big benefit for humanity.
Yeah.
And I guess thanks you for. Sir, do you have something to say?
No.
Okay. And I guess that's it for our forum and our Q&A for your part of the program, sir. And maybe let's give him the token of gratitude. So as a token of our gratitude, we would like to give you the certificate of appreciation.
The certificate reads, the Certificate of Appreciation, the Association for Computing Machinery UP Diliman Student Chapter Incorporated awards this Certificate of Appreciation to Jewel Joseph Arroyo for being an esteemed speaker at UP ACM Fest 2022 Destinations held on July 23, 2022. Thank you so much for imparting your knowledge with us.
Thank you as well for having me.
Thank you, Sir Jewel. And I guess for let's have a quick snapshot with our speaker to commemorate this event. So
yeah,
here,
someone will be having like someone's gonna take a photo. Okay, there you go.
Sige. Sige, 3.
Okay. Let's just confirm with the team if that okay. So yeah, the photo was taken. Thank you so much. And as promised to our participants, we will be having another raffle draw for the people who are able to attend. So the raffle draw gives participants a chance to win 500 pesos. So remember to register so we'll be able to contact you. The person who will win will be contacted also through Zoom. So okay. So our winner for the second raffle draw is Angela Pelagio.
Congratulations, Angela. And we'll be contacting you after this event.
Yeah, so expect a PM from someone on Zoom. And if you have other people you want to like call for the last talk, they can also qualify for the raffle since we count it for every talk and not just for the start. So if you want to call on some friends, you can. There. Okay, so congratulations to our second raffle winner. So we'll be contacting you like through Zoom PM, and we also suggest that if you haven't registered yet, just register. Okay. So
all right, so before we move on to our final stop, I guess let's refill our tank here and break muna tayo, guys.
Yeah.
All right, so same as last time, this break will last for 15 minutes and the main program will be returning by 3:45 p.m.
So see you in around 15 minutes. I'll see you at 3:45.
All right.
Life starts changing when ideas come to life.
We continuously improve. We innovate.
We create space for creativity. We're not just colleagues, we're a collective here.
This is what we love doing. Because ideas can change the world.
It's very hard for you to provide for your family. Freelancer has helped me to overcome all that.
My life dream is to go to Japan. Thanks to my freelancer.com incomes, I have been able to save enough money to make this dream a reality.
Thanks freelancer.com for this wonderful idea to pull out the creative stage from the shell in front of the world.
Hi, I'm Greg.
Hello, I'm Jean.
Hi, I'm Justin.
And this is an example of
The day in my life as a software engineer
at Expodoc.
Wake up.
I'm getting ready for my stand-up meeting now.
Morning stand up.
All right, let's do some work today, guys. Go team. Yeah.
Work.
It's currently 9:30 a.m. I'm checking my calendar right now for my meetings, going through my emails, checking my Slack, also having some breakfast.
Figure out how the heck to do my task.
I'm done with all my morning meetings, so now I'm gonna go back to fixing my draft PR. Hopefully it'll be up soon.
Team building.
It's 12:30 in the afternoon, so I'm gonna head out for lunch.
Super mega ultra power coding. Have lunch and pet dog.
So I just finished lunch and I got my caffeine for the day.
Stir, stir, stir. Bugs. Back to work.
Oh my god, it works.
Great. Success.
So it's almost 5 and I'm getting ready for my second stand-up of the day. And after this meeting, I'll probably wrap up and be done for the day.
Play some TFTLMAO.
Education matters to us as much as it matters to you. We know that in teaching students, we make sure that they're one step closer to their dreams. With Course Hero, you can be a part of a growing community of passionate educators who are willing to help students learn. Our online learning platform gives you the opportunity to provide explanations to student questions and to share study resources for specific courses. Think of it this way: when you explain, you gain. So, what are you waiting for? Be a tutor now.
Education. It starts for all of us with a blank piece of paper. And then it leads to knowledge, curiosity, and discovery. Worlds open. Minds expand. But the road gets more challenging. And no matter how brilliant we may be, at some point, we all get stuck. So Course Hero did something about it. We set out to get students unstuck. And we made it our mission to help more people graduate confident and prepared than ever before. Today, Course Hero can help students with virtually any course at any college, anywhere in the world. And we're leveling the playing field for all, from students with children, to students with jobs, to students who are just plain in over their head. But we still have a long way to go. Creating a world where every student graduates is an incredibly rewarding but incredibly massive challenge. It requires finding the world's best problem solvers. It's engineers building the world's largest educational content marketplace. It's AI specialists building personalized learning and teaching tools. And it's designers and marketers who share a passion for what we do. We're also a great place to work, and it goes beyond ping pong tables. Walk through our doors, and you can actually feel the collaboration and energy. We are Course Hero. We are a hyper-growth company that is changing the way students learn and making a meaningful impact all over the world. Help invent the future of student learning.
Hey there! Looking for a no-hassle side hustle? I'm here to introduce you to a text-based Q&A platform where you can earn by tutoring whenever and wherever you want. Welcome to Course Hero. Course Hero is an online learning platform of course-specific study resources. It's a platform for students around the globe to get 24/7 homework help. As a text-based tutor on Course Hero, you can help students learn by writing step-by-step solutions or answers to student questions within your specialized field on the platform. You can choose your subject expertise, from computer science to engineering, science to math, and everything in between. As a tutor, you can answer questions in your subject expertise and help over 10 million students. It's up to you to decide whether you want to go for regular or more complex questions. No need to worry about compensation, as you'll be paid per question answered instead of per hour. Enjoy the flexibility and freedom to be a tutor on Course Hero whenever and wherever you like. So, you might be asking, how much can you expect? The base rate for questions is $3. But for more difficult questions, there are complexity bonuses. Top-tier tutors can earn around 1,000.
Hello, everyone, and we're back. So, hopefully, everyone has heeded to the calls of nature and are ready for a long drive towards our final stop for today.
So let's end the day on a high note with today's third and final guide of this journey.
He holds a master's degree in finance from Cambridge University and was an investment banker.
He is the founder of City Munch, an award-winning startup offering real-time restaurant deals in the UK.
He is also the co-founder of Old Street Labs, a London-based product development agency with a strong presence in the Philippines.
He will be our guide for today's last stop, giving us a talk on driving entrepreneurship, building tech for international startups. Let us all welcome Mr. Rob Lynch.
Hello, everyone. Thank you so much for having me. It's an enormous pleasure to speak to everyone here. I hope everyone's had a good day. Guys, can I share? I can share my screen, right?
Yes, you can.
Perfect. Okay. Can everyone see my screen?
Yes, we can confirm you can see your screen.
Great, thanks a lot. Right, well, I thought I'd speak today about driving entrepreneurship. There was a little bit about my background there. The very first and most important thing to say is I myself don't have an explicitly technical background. So for the Q&A at the end, please bear that in mind. Instead, I've been through this journey. So driving entrepreneurship, building tech for international startups. Well, back in 2016, I launched a startup called City Munch, which was mentioned briefly there. So this was an app for restaurant deals around London. In the pandemic, as soon as the restaurants, every single restaurant shut down, and along with it, my much beloved startup, unfortunately. But as you can see from the screenshot of the app itself, we were based around a place called Old Street, and City Munch morphed into Old Street Labs. So this is the company that I run at the moment. So Old Street Labs is called Old Street Labs because that's where we were based in London. This is the center. It's kind of like the Silicon Valley of London, if there is such a thing. There's a roundabout somewhere in northeast London called Old Street Roundabout where a lot of the tech startups are based. So that's what I do now. So I run Old Street Labs with a partner in the UK, but the vast majority of our team are based out in the Philippines. There's about 35, I believe, of us. There's a tiny bit about me. Another thing about me is I'm an enormous history buff. So although this might seem slightly out of place in a tech talk, I thought I'd just tell you a quick story about three 19th century Swedish brothers. So this is Robert, Ludwig, and Alfred. This is basically just an example of tech innovation and entrepreneurship going together, because the two are almost inextricably linked. Entrepreneurship has, since the very early days of the Industrial Revolution, been driven by tech innovations. And this is just a little bit of a story about that. So Robert and Ludwig, two Swedish brothers, they went to Azerbaijan in the early 1870s. The first oil well had been drilled in the world, had been drilled around there, around the enormous oil fields of Baku in the former Soviet Union, now Azerbaijan, in the late 1840s. And they cottoned onto that. So they're known, especially Ludwig is known as the father of the Russian oil industry, and built pipelines, and most importantly for this purpose, built a research lab right next to the oil refineries. So you had techies working and scientists working together, continually coming up with commercial innovations that could help. And one of the key problems they had at the time was the difficulty of transporting oil. It wasn't safe, and that just the nature of having an enormous amount of oil in a ship meant that it went back and forth, and actually transporting it was very hard. So out of this lab emerged the world's very first oil tanker. So by allowing the liquid to expand and contract, and by making sure that the dangerous fumes were nowhere near the engine room, he made it a lot safer, and the oil tanker was born. So that innovation, coupled with other innovations like the internal combustion engine, drove an enormous tech entrepreneurship boom around the beginning of the 20th century. And by 1990, so these are the 5 biggest firms in the US in 1990: General Motors, Ford, Exxon, IBM, and General Electric. By that stage, all of these companies are around 80, 90, sort of even up. Exxon, in Exxon's case, 130-ish years old. All of these pretty much can be attributed to that initial entrepreneurship boom, possibly arguably not IBM, but Exxon's directly oil and gas, Ford Motor and General Motors. So obviously, again, the internal combustion engine and oil combined to allow this immense kind of flourishing of entrepreneurial and tech activity at the beginning of the 20th century. And that wasn't really that didn't really change. Like, all these companies are still there in 1990 as the biggest companies in the world. Fast forward to 2022, and we're now in another boom, so another tech boom, where entrepreneurship has been driven in the last 40, 50 years by technology. The fact that Apple and Microsoft are at the top of this, and they're actually kind of rather old, I think masks the underlying reality, where there are a heck of a lot of technology companies that are as old as or much younger, in fact, than Alphabet or Google and Amazon, that have come up and just completely taken over the business world in the last 20, 30 years. Even the one which possibly doesn't qualify as technology, Tesla, as it's really a car company, is heavily based around new technology. So tech and entrepreneurship are peas in a pod. So what is a startup? So you might recognize these two figures. This is Travis Kalanick, who was the founder of Uber, and of course Elon Musk, the founder of Tesla and SpaceX and a whole host of other things. This to me is the sort of the public perception of a startup, where it's men on stages, talking to crowds in a very earnest way with very similar hand gestures by the looks of things. The point that one of the key points I want to make is that this couldn't really be further from the truth. Firstly, these companies share very little in common with entrepreneurship, with true early stage startups. They're public companies. They have enormous resources, and they've long since left that initial stage. That initial stage when they're truly taking entrepreneurial risks. So a few more fairy tales. So startups are companies like Uber, SpaceX, or Instagram. As I say, these companies are absolutely not startups in my view. Another fairy tale here: startups have loads of funding from Silicon Valley venture capitalists. This is also an incredibly rare thing at an early stage. Obviously, some companies do go on and raise significant funding, but it takes a long time for venture capitalists typically to be interested in startups, and oftentimes these are one or two people with a concept that they're working on a really shoestring budget. So they're working with their own capital. Maybe they've saved up some money in the bank. A lot of people have to put their life on hold in order to take the plunge into entrepreneurship, and it's not for the faint-hearted. Startup founders are crack teams of techies trying to build a unicorn. I don't know how many people will have heard this phrase unicorn, but unicorn is shorthand for a billion-dollar startup. Startup founders are often, nowadays at least, but back in the day, I think it was sort of more common for teams of techies to start startups, and it certainly still does happen. There's Web3, NFTs, and AI being areas where a lot of startups are founded around teams of techies. But the reality is that many entrepreneurs are domain experts, so they're people in all sorts of industries who have spied an opportunity, a way of doing things better in their specific industry that no one else is really privy to. No one else could have was necessarily in the position to spot these opportunities, because they themselves have the inside track on how the industry is run, and the chances are they'll be in a better position to affect the startup because they have the network in that industry. So final fairy tale: startups fund themselves by going to venture capitalists with an idea. Again, it takes a while for venture capitalists to be interested in startups. Gone are the days when a venture capitalist would invest in a startup based on a business plan. Nowadays, you need to have a working product, ideally. You might be able to, as an entrepreneur, raise a little bit of funding from what's called angel investors, very, very early stage investors, with a working prototype of a product. But to raise any capital that's going to keep you going for a long time, realistically, you need a working product and proof that there is a market need for that product. So hopefully I've gone and slashed a few fairy tales there. This is more like the reality. So this again is the same person as this. This is Elon Musk back in the 1990s. This is one person looking considerably less stylish than he did there, at his computer, solidly working night in, night out, and trying to forge the beginnings of a product. So the way it was, in the heady days of about 20 odd years ago, when the dot-com bubble was going on, an entrepreneur would write a business plan, they'd go to investors, they'd raise money with this pitch deck with suits on and with a team of highly accomplished professionals. They'd raise that money, and then they would go away and studiously execute that business plan. This is an example of what happened when that was tried. So this is the story of Webvan, who were founded in the US in 1996. I think they were founded by the original founder of Borders, which is a chain of bookstores. So they had a very accomplished team, dating back with decades odd of experience. And on the strength of their business plan, they raised venture capital of a whopping $396 million. They launched in June 1999. In November 1999, they raised a further $375 million. They executed the plan, so they went just point by point by point. The idea was to essentially do online shopping, so online shopping for groceries. So you can see the telltale signs giving that away in their branding. You have Webvan there with a mouse pointer here, and a grocery bag there, and that's what they were trying to do. And the truth is that this was this was a market that didn't exist yet, and the customers weren't ready for yet. Obviously, online grocery shopping is a thing now, but back in the late 1990s, with what the web was then, people were very reluctant to give card details over at all to anyone, and there were a whole host of user experience imperfections around the online shopping service that people just simply didn't want at the time. And someone somewhere realized that, did we really need to burn through the best part of $800 million to figure out the answer to a simple question? Do customers want this? It's not necessarily an easy question to answer, and just simply asking customers might not be the way of doing it, but surely there's a better way than spending 800 million. So that was the thinking in kind of 2010-ish, when Webvan and a host of other similar stories started to come out. This is still a problem. So in the top 10 reasons that startups fail, no market need is the most common reason. Ran out of cash, I think it's a little bit of a misnomer of one, because they could have ran out of cash because no one was, they couldn't raise money because they couldn't get revenue, because again, there was no market need. So in my mind, that could be even higher. The point here is that the most important question to answer is, are you building something that people are going to want? And that was a question that this man turned his mind to in 2011 with a book called The Lean Startup. So I don't know how many people might have heard of this or read about it. But this was the lean startups theory, that there are ways and means of finding out what customers want incrementally. So you don't need to figure everything out, but ways and means of finding out what customers want bit by bit, without just going through the motions and executing your business plan and assuming that the customers will come. So this is the basic lean startup theory. We can build a small product. We can build something, anything. We can come on to at least one example of what that might be in the first instance. Measure its effects, so measure what people do with that product, understand why they're doing it, speak to customers, collect survey data, use all the techniques that you can think of to measure the impact, learn from that. So deduce, okay, well, what do we have to do now? We've learned a little bit more about the market and what customers actually want than we used to know, and then rinse and repeat. So the very first product that startups build, and this is a phrase that I'm sure a lot of people would have heard of, but it was started by Eric Ries in the Lean Startup. It's the MVP, the minimum viable product. So the idea of the MVP is to build the smallest possible product, do the least amount of work, frankly, that you can, in order to test whether, in order to test your hypotheses. So the idea of the lean startup is kind of following the contours of the scientific method. So those of you with a scientific background know that the basic idea of the scientific method is to start off with an initial hypothesis, collect that empirical evidence, collect the data to either validate that hypothesis or invalidate that hypothesis, and then learn something from it, evaluate it and conclude, and then possibly work towards a more a more informed experiment next time. And that's a very, very good analogy as to what a startup is now. A startup is it's a series of experiments in order to find something called product market fit, right? So in order to find in shorthand, a product and a service that customers are going to want. This is not a simple process. The other important bit, of course, is raising the funding. And as we mentioned before, simply going to investors with a business plan is not enough these days, but going to investors with that empirical evidence, with that data, and explaining what you're doing in order to learn from that data and developing the possible series of hypotheses that you want to test in the future and explaining that to investors. With that mindset, then it's still difficult, but you got a chance. So an example of this, so what's if we really want to work out what customers might want, and we really want to do the least amount of work. I don't know whether anyone's heard of this, but there is a technique that's used called the fake door, which you can see this woman seems to be going through right now, a fake door. But in technical terms, what a fake door is shown by this example from Buffer here. So Buffer is a social media management platform. This dates back to 2010. So this is the early days of the general thesis around lean startup. They put out a page just indicating the very simple value proposition of what their business does. So you choose times to tweet, you add tweets to your Buffer, and Buffer does the rest. So you can just load up a load of tweets, and for people that are social media managers and tweeting 50 times a day, that's a pretty useful thing to be able to do. You don't have to constantly be on the clock and constantly set your alarm for when you want to tweet. You can do it all in one go, and then you can devote your cognitive efforts in another direction. So the fake door is this. We put up something with a value proposition. We put a big call to action there, a big button saying, do you want it? Plans and pricing. And then it's a fake door. We don't actually have the product, guys. Sorry. You caught us before you're ready. We're working hard to finish this. But what they managed to do is collect the emails of people who might want it. They can measure, again, build, measure, learn. They can measure how many people came to this page and the proportion of them that were interested enough to click plans and pricing. And they have a load of email addresses that they can then contact and understand them better, give them surveys, speak to them on the phone, take them for coffee, whatever it might be. And that you could probably put this together. I'm sure some of you guys could put this together in an hour or so. And so you've spent considerably less than $800 million in order to find something potentially very valuable. So the reality is a very bumpy process for a founder of founding a team, coming up with the original concept, then getting into this lean startup mode of, okay, we've got a minimum viable product to test out our hypotheses. We can iterate. Iterate and pivot is another word that's used very commonly, which is just essentially a fancy way of saying we change the direction of the product with one foot in the past, one kind of foot in what we've learned from previous products. So we're iterating the product, and eventually, hopefully, we'll find something that works, product market fit, and then we can scale up. Now, the ideal founding team for a startup, is the what's it called? Just the general pattern of an ideal team is made up of a hustler, a hacker, and a hipster. So this is someone who can sell the products. The hacker, obviously, very important. Someone who actually builds the product. And the hipster is slightly less well defined. It's in my mind, this is the domain expert. This is someone that knows that knows the market well, can understand the customer needs, and this could be an accountant. It doesn't have to be someone that might fit the mold of a hipster. It just needs to be someone who is who comes with the domain expertise. An example of that, so a lot of you, I'm sure, recognize this man. This is Steve Jobs. He was a great salesman, but he didn't do it alone. He did it with the help of, most famously, Steve Wozniak, who was the technical brains behind Apple in the early days. And this man, who's less famous, who's Johnny Ive, who is the designer behind, I think he joined in around 1992. So for anyone as old as me that can remember something called an iMac, it was an extremely stylish computer that broke the mold of the Dell Hewlett-Packard PCs at the time. And obviously, Johnny Ive was very much involved in the first iPods, then iPhone and iPad, etc. But the reality is usually, in our experience at least, a bit different. It's usually one or two people, maybe three people, that have domain expertise, some of it, but not necessarily all of it. Hence, I've cut off this man's photo here. And they'll probably have a certain amount of sales skills. The part that they're usually missing is the tech. So it's a couple of people with, this is supposed to be an idea written on a napkin with a cup of coffee for good measure. So these are the people that we deal with. So this is some shameless plugging from our website. So at Old Street Labs, we'll take the founding team like this. And the idea is to take them from napkin to launch. That's our glib little phrase. So a founding team with an idea written on a napkin, that they need their hands held through the process to actually develop that first MVP. The whole build, measure, learn process is, again, not a simple one. I think a lot of people now, a lot of entrepreneurs have a general feel for it and the direction that they need to go, and they can't afford to build something big anyway. They don't have the $800 million to play with. So in a way, they're forced to be lean, but to truly do that well and to say, okay, where is the market need? What are we going to build? How are we going to design it? It's not such a straightforward process. So typically what we would do is take our entrepreneurial clients through this definition and design phase for about 6 weeks to 2 months, really hammering out what exactly they are, what problem they're looking to solve, the users that they're trying to target, how they're trying to do that, so what solution they've come up with. We'll take them through the design phase, and obviously most importantly is the development phase, which it clearly takes the longest period of time. But I think it sort of illustrates in a way the point that spending a bit more time, if we spent double the amount of time on the definition phase or double the amount of time on this, it's not that much in the grand scheme of things. It's much better to spend time here working out the MVP, the really truly minimum viable products, than it is to risk building too much and sort of wasting everyone's time and money. So product definition can look a little bit like this. So as the ultimate goal of the definition phase is to come up with a set of wireframes, but typically before that, again, that there's more involved around developing the user flows and journeys and helping the client think through who their likely customers are. Designing is making it look pretty, and hopefully we're pretty good at that. And product development. So there's a lot to say, I think, on product development for startups specifically, and the thought process and the mindset that needs to go into developing products for startups compared to say an international bank or something. So the lean startup process that we're starting with builds more ventures more efficiently. It has 3 parts: a business model canvas to frame hypothesis, that's just a simple business plan; customer development to get out of the building to test those hypotheses, that's speaking to customers; and agile engineering to build minimum viable products. I should have mentioned this is a quote from a man called Steve Blank, who, along with Eric Ries, who I mentioned earlier, is one of the founders of this way of thinking. I suppose that the main phrase that I want to draw attention to now is agile engineering. So we know what we want to do. We've got to build a minimum viable product in order to test our hypothesis. How we do that is through agile engineering. Now, what's agile engineering? I might be preaching to the converted here. This might be something that everyone knows, I'm not entirely sure. But agile engineering contrasts with the way that tech has been built for a long, long time through waterfall methodology. So this is how tech was built. Requirements were gathered and documented. Designs were made and documented. That an enormous tech spec was put together, and that was followed to the letter, and that was then tested and ultimately maintained. That sounds pretty sensible, but again, the issue here is that with a lot of startups, because they don't know really what they're building and what they need to build, a full set of documentation to describe an entire product typically isn't the best way of doing things. What we instead need to do is break that up into chunks. So what agile development does is to break everything up into 2-week sprints, and a sprint is almost like a mini project. It goes through its own planning phase. The documentation that's written is there, but it's minimal compared with waterfall. And every 2 weeks, we look at exactly what needs to be done as a team, come together in a sprint planning meeting. We estimate out the work, we split it out, and we, after the end of every 2-week sprints, we'll produce working software. So the idea is to demo something to the stakeholders, in this case the client, and say, this is a product increment, this is work that we've done in the last 2 weeks that has that is demonstrably working software, and literally will share screens, show buttons working, etc. This is extremely helpful for the client process, even at the very beginning, even if all you're showing the client is a login screen with some semi-working authentication, then taking the client through that, showing them how it's working in practice, enables much closer collaboration, because they can immediately say, oh, hold on a second, I actually meant this, which isn't great if if a miscommunication has happened, but it's a heck of a lot better if it happens in this framework than if it happens in the old waterfall framework. Waterfall was kind of well, it's characterized by this little cartoon. So this person's saying, we're planning an expedition to a part of a jungle where no men have ever been. Wow, that sounds exciting. And how will you find your way there when you're there? That'll be easy. We've already spent 6 months to draw up the maps. Now, clearly, maps drawn up about a jungle that no man's actually ever physically been to are not going to be so useful. And you've spent 6 months doing it. So the idea here is that by actually doing and getting going quickly without tons of documentation, and by continuing to collaborate as a team and undergoing some pretty defined sort of processes of coming together and meeting, we can operate effectively as the support team to an entrepreneur who lives in a world where everything's changing all the time. Hopefully that bit made sense. So the Agile Manifesto, this, you can actually go to, I think, a website called theagilemanifesto.org, or Google it, but something like that. When it was first put together by teams of developers, they just came up with some pretty simple statements, but statements which were pretty revolutionary at the time. So we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. The thing, I guess I'll just point out a couple of things here. On the right-hand side, there's a lot of paperwork. So we don't like paperwork. Comprehensive documentation, don't like that. Contracts negotiation, paperwork, don't like that. Following a plan, don't like that. Processes and tools, okay, possibly not so much paperwork, but again, it's sort of something set in stone. So the value is placed instead on this left-hand side, where I think if we're going to characterize the right-hand side as sort of paperwork, would characterize the left-hand side as teamwork. So customer collaboration. So it's customer collaboration, I would say, and team collaboration. Responding to change, again, so communicating and understanding what those changes are as team, individual interactions as a team, working software, again, not explicitly team, but yeah, an important part of the agile process. So how this looks in practice, this bit in red here is a 2-week sprint. So we plan the sprint on one day. Every single day we're meeting up, the daily stand-up. We're refining the backlog, which means we're going over our to-do list as a team. We're going over the product roadmap, and we're making sure that we understand in some detail what needs doing. We're continually meeting, and then we'll have a review and a retrospective at the end of the sprint. So again, the compared to the old waterfall world, this really places the emphasis on team collaboration. So the team in this case, the way we set things up, at least, so a client lead, that might be me, a project or product manager, team of developers, typically could be anything from 2 to 6, a UX designer and a QA tester, and all of these people have to come together on a daily basis to meet and discuss the project, any blockers that anyone has, and make sure that everyone is aligned. Might skip this one. This is a cartoon that I quite like that you might have seen a version of, but the main illustration, I suppose, is the ease with which projects can falter, can fail due to miscommunication. And I think there are probably figures on it, which I might dig up for another presentation in the future, but software projects fail. When they do fail, it's or do get pushed back or go over budget, etc. It can very, very frequently be due to people not communicating perfectly, and no one's perfect, but an emphasis on communication and collaboration are paramount. Scrum in practice, for those that are interested, typically would involve this kind of thing. So a sprint board with specific tasks that are moved through the pipeline, and this is the kind of screen that we'll be looking at every time we run a sprint planning session. The title of this talk was Building Tech for International Startups. So I think I should probably focus a tiny bit on the international bit. I actually don't think this is too important, but it is worth noting that dealing with, we mainly have customers in the UK and the US, and even, you know, the UK and the US are pretty different places a lot of the time, and knowing the difference between those customers and the kind of assumptions that they're coming in with, the cultural ways of doing things that British people have compared to American people have, they are different. I did quite like this Finland one. I don't know how many people have friends or contacts in Finland, but they have a pie chart that seems to be saying they're just listening all the time. They never give feedback and need a lot of coffee. So not sure how easy it would be to do business in Finland. So a quick example of some of the work that we've done, and one of these startups, we worked with a psychotherapist who, again, he's a domain expert. He saw the problem which was that although there's the fit between a client and a therapist is incredibly important for outcomes, so the relationship between them, there's no effective way of fitting the two together, of matching the perfect client with the perfect therapist. So together with him, we designed a matching app which collects survey data from both therapists and clients, and uses matching algorithms to hopefully combine the two, which will ultimately be driven by machine learning algorithms. Secondly, this is actually a product we're working on at the moment. Again, we have a domain expert. We have a music producer in Tennessee in the US. This is essentially a booking system for studios, music studios, which still seems to be stuck in the 20th century. But it's also a way of musicians and those in around the music industry to find each other and collaborate. So you can look for a sound engineer or a session musician using this app. That's quite a fun one. So what does it take to be a developer that works with international startups? I've got 5 things. I prefer images to words. So we've gone for this one, which is a passion for technology, an eagerness to learn. And I think these two are sort of inextricably linked. If you really have a passion for tech, then for sure you'll want to learn more about it. This one is collaboration. So again, I've rammed that home, but we're always working in a team, and the ability to do that well, to be a team player, to help someone out if they're struggling, to ask for help if you're struggling is incredibly important. Linked to that is communication. We ask, so all of our developers speak to clients, not much at a junior level. It's usually just a sort of a case of saying, this is what I've done, and possibly answering a couple of very specific technical questions. But as people go through our business, then we like all of our developers and designers to be able to speak to clients. But I think more importantly, it's about communicating within the team again. So, I mean, I suppose it's sort of similar to collaboration in that sense. And this one is just confidence. Now, an absence of confidence can lead people to get stuck on a problem and not feel that they can ask questions about it, not feel they can speak up. And occasionally it can also lead to people being a little bit not communicating when they're struggling. So, you know, if the deadline's Friday, it's great that we know that you're struggling to meet that deadline on Monday. It's not so great to learn that we're struggling to meet that deadline on Thursday night. And finally, it's important to have a bit of a sense of humor, not take yourself too seriously. Not entirely sure why I selected this image for that, but we like to think, at least, that we have a friendly team that can come together and have fun from time to time. And in fact, I think half the team are meeting up in Manila today for drinks and things. Very finally, and I know you're probably all itching for me to finish, but I didn't mention brother number 3. So Ludwig and Robert went off to Baku to found the Russian oil industry. Alfred was an incredible techie and entrepreneur in his own right, and he has about 350 plus patents. The most famous patent that he had was dynamite. So he managed to safely harness the explosive power of nitroglycerin. Don't ask me to explain that in any more detail. And dynamite became incredibly useful in the mining industry and quarrying industry, among others. And he became a very wealthy man. Now, in 1888, Ludwig dies, but the press at the time, I think it was a couple of French newspapers, got it wrong, and they said that it was Alfred that died. And so there was an obituary in the press for Alfred. So he had the dubious honor and probably fairly unique experience of reading his own obituary, which was not kind at all, and called him the Merchant of Death, because obviously dynamite was also used in war. So when he read that he was being his legacy to the world was being a merchant of death and generally wreaking havoc and misery, he decided to leave his fortune to not to anyone else, but to the furtherment of science and technology through the Nobel Prize. So, of course, these are the Nobel brothers. So, hopefully, he managed to make up for a little bit of the havoc that he wreaked on mankind through his furtherment of the explosives industry. Anyway, I thought that was a nice little story that I would share with you all. Thanks very much for listening, everyone. Very happy to take questions. But that's my email address if anyone wants to get in touch. And we are we're always looking for great developers, product managers, and any potential designer. Even no experience, certainly developers and product managers, it's mainly potential that we tend to look for rather than experience. And we do have a graduate program. Right now, there might be limited spots, and we're kind of running the graduate scheme at the moment. So I don't want to overpromise, but certainly we're hiring. We're hiring at some stage. So keep an eye on our website for anyone that's interested. All right, that's me.
All right, hear that, guys? They're hiring. So send your resumes to the details presented by Sir Rob in his ending slide. So I think it's really interesting to see how we've become smarter in doing everything, even in building startups. I think it's really amazing to hear from a perspective of someone or of a company who essentially become the hands of brains from all over the world itching to to make their ideas come into fruition. And it's a really fun and exciting story to hear as a college student right now. So I guess we'll start off with our Q&A session for you, sir. And maybe Macy can get the first question from our audience.
Okay. Let's actually, yeah, this is a pretty interesting question. With the recent boom of tech startups, what are some distinguishing qualities or features that an investor is looking for in a product and or the founder?
Yeah, that's a really interesting question. I think a lot of early stage investors. So at that stage where we tend to deal with, where people are at that very early stage, the emphasis is very much on the founder or the founding team rather than the product. I mean, there's certainly a bit of both, but for the investors that we talk to, it's a heck of a lot of it is the founding team, because you really need to be exceptional to make it work, and the team needs good chemistry. They need to have worked together for a number of years, and they need to demonstrate that they specifically are the ones to tackle the problem that they've identified. As far as a product is concerned, I think it varies a lot from investor to investor, but the one thing that's common, I think, is just some kind of data, some kind of real reason to back up the thesis. So empirical data that consumers actually do want the product, and ideally that means people actually using an MVP. So that's a lot of the time that's where we come in. We'll produce the MVP, and startups can go to investors with that MVP, show it working, and show people using it, and show some feedback from it. And if they can get to that stage, then I think they're in a very good position. There are certain kind of, obviously there are certain buzz areas right now. So NFT, well, Web3, I suppose, and anything falling under the rubric of Web3 is very popular generally. But I think that it's these fads can be overemphasized, and good investors will always look for the high quality of the founding team and some evidence to back up the story.
Yeah, that's a pretty important things of like how do you distinguish like a good team versus like a bad team. I think we can move on to our next question.
All right, this is a question I'm also curious about. If fake door testing doesn't work, what other options do we have for figuring out what the customers want?
Yeah, great question. Yeah, fake door testing it was really just an example. I think it's quite an illustrative example because it just shows how you can get quite far with doing very little in the way of tech. As the question implies, it isn't always that simple, and you don't get that far with fake door testing anyway. I think oftentimes there's no, well, the real answer is that at some stage you are going to have to build some kind of MVP, but the identifying what that really is and whittling it down and shedding it of any fat, any features that it doesn't need, and making sure that you just don't spend very much time developing that first product that's a very, very difficult thing to do, and everyone gets it wrong to some extent. So that's the kind of I guess the sledgehammer answer is an MVP. There are other little techniques that you can do. I think there's no substitute for talking to customers. So one of the phrases in Steve Blank's quote was get out of the building, which he when Steve Blank was a sort of a prominent speaker, which to a large degree he still is, but he kept on saying to founders, get out of the building, get out of the building. And that's because a lot of founding teams wouldn't do that, partly because possibly a lot of them didn't have the hustler, and a lot of them were techies at the time, and they're focused on building the product, and it can be very uncomfortable for people to continually go into sales mode. It's not an easy thing to do. And when I was building my startup City Munch, you just had to walk into a restaurant with a bit of paper or some designs or something and ask to speak to the manager and show them a few designs and like, would you use this, and try and understand them. And that's not an easy or comfortable thing to do. And you might just say, well, entrepreneurs should just be able to get over themselves and do that. But whether they do it enough and whether they really put their heart into that can often depend on their personality. But so that's one thing I'd say is just somehow getting, somehow speaking directly to customers, even if what you're building is a consumer product with, where you're targeting millions of people. So what good is it to speak to one person? Well, if you speak to 10 people, you'll probably learn something. So again, it's far removed from the actual business of building the product. So it can be overlooked, but it can be very effective.
So it's like a very relational approach in terms of creating products and making sure that there are people who are willing to kind of take a chance on the product, try it out, maybe are interested to use it. So it's just a person to person type of thing, especially for startups.
Yeah. I might add that surveys are often very useful too. So if you have an email list, if you're fake door testing or something has given you an email list of 100 people or so, hopefully 1,000, then a simple survey of 10 questions can get a lot more data quicker. So you can do that too, but I definitely think there's no substitute for actually speaking to people in person.
Okay, we can move on to our next question. I think, the question here is, what are some beginner/rookie mistakes that someone who might want to have a startup make? So it's what are some skip over these because these aren't necessarily helpful things?
Interesting question. I've already said this about 3 times, but the one thing is just making sure you don't overspec that first product. So hopefully everyone's got that message now, but finding the actual MVP and not overspecking it is it's so easy a mistake to make that that I think people do need to be told multiple times. I think, well, I probably would say this, but assuming that you can do everything yourself is a mistake that some people make, and not getting help. So whether that's mentorship or finding the community, or dare I say hiring a firm like Old Street Labs who've done it multiple times before, it's for a startup. I think that's a big mistake. Another thing is just not telling anyone about your idea. There are quite a few sort of first-time entrepreneurs in the early stage who will keep their ideas secret because they think that someone will steal it, or that it's their secret sauce that they don't want to give away. That in practice, that shouldn't be a concern. If you tell anyone your idea, the chances are they'll think you're probably mad. And actually executing the idea is incredibly hard. Ideas are sort of worthless. That I was a bit hesitant to use the word worthless there, because it's not always true, right? There are some concepts that are so brilliantly thought out that the secret sauce truly is within the concept, and actually the execution, while difficult, is not impossible for someone else to do. But I think those are extremely rare, and most of the time the difficult part is actually executing. So I'd advise people to be as open with their ideas as they can, and getting feedback from, whether it's family, friends, mentors, college professors, colleagues, anyone.
Thank you for that. I think we have time for one last question.
All right. There are still a lot of questions here, but I guess I just need to pick one. And this is a really interesting one. It's not a question, but it's a call for advice. What's your advice on how an aspiring entrepreneur can reach international markets?
That's a tough question, because I think it depends a lot on the nature of the products that you're trying to sell internationally. I mean, obviously the web makes a lot of this much easier than it used to be. And for example, a SaaS product is, if it's applicable to someone the other side of the world, then it's very easy to reach that person the other side of the world. But in terms of actually marketing a product and selling it, I think trying to understand and trying to be specific about who exactly you're trying to target. In today's world, I think it matters much more the persona that you select, rather than any particular nationality. So there are techies in every country. There are tennis fans, or runners in every country. So I think it's probably more important to nail down the community of people, the kind of cultural community, or the persona that you're trying to target, rather than the country itself. And those people are accessible online through through any social network, right, Reddit or whatever, and trying to understand how that community interacts and thinks, I think, is the important thing. I kind of feel like I've slightly dodged the question, but I think that's what I'd say. I think that focusing on the community rather than nationality is where to go.
Okay. So thank you so much for like imparting your knowledge on startups. I know we have we had some more technical topics earlier, and now we have like something more about actually it's technology related, but it's actually a very interesting topic that I think a lot of especially for here computer science students may not necessarily know about, which is like the implementation / tech side of a lot of different companies, which we can already see with some tech CEOs. The developers usually get kind of out of the spotlight, so it's really cool to be able to kind of see that area of like startup culture and like just how it manifests. Okay, so that is the last destination, but definitely wasn't the least. But as a token of our gratitude, we would like to give you this certificate of appreciation. So the certificate reads, the Association for Computing Machinery, UP Diliman Student Chapter Incorporated, awards the certificate of appreciation to Rob Lynch for being an esteemed speaker at UP ACM Fest 2022, destinations held on July 23, 2022. Thank you so much.
Thank you so much for having me. That's lovely. Thank you.
Right, I guess we can have a snapshot with our speaker to commemorate this event. So someone from the committee will take a picture for us. So I guess we can do 3, 2, 1.
Okay.
AC, can you confirm if the picture was taken?
Yeah, the picture was taken. Okay.
All right. Thank you, sir.
Thank you so much. Okay, so for our participants, we will be having our final raffle draw for the day. So for the people who maybe just entered, we have a 500 peso draw for the attendees of each talk. So our winner for talk number 3 of ACM Fest Day 1 is Gabriel Kalubayan. Congratulations. So please expect a private message through Zoom to collect your contact information. There you go. And then, yeah, I just want to remind everyone that if you have not registered yet, please register so we would be able to give you updates about ACM Fest.
Congratulations to all of our winners, and congratulations to all of us for gaining more new knowledge after all those 3 talks. All those 3 talks today. That was such a learning filled day, and we got to see 3 new perspectives in computing from various industries.
Yeah, we had a deep dive on personalization alongside a crash course on machine learning to see how it enables us to make content convenient and relevant to a lot of different users. We even got to see an end-to-end example that uses the data infrastructure, machine learning, and integration as foundations of its system.
We also learned about knowledge engineering, where we can make machines develop knowledge towards wisdom to reason like an expert. There was even an introduction of triples and connections in an RDF model to tackle complex problems.
finally, we had some interesting stories about the lows and highs of different startups, how it actually is, and how it goes hand in hand with technology. In the lean startup process, it even goes through like the concept of like agile versus waterfall, and how it leads startups to efficiently develop themselves incrementally.
So, dear speakers, we're grateful for taking your time to show us these things. So, let's save the moment and have one last photo for the day.
There you go.
Right. I guess
we can stop the screen share
for
for now.
Yeah, I guess we can stop the screen share for now. And for participants who are here in the Zoom meeting, I guess you can turn on your cams.
So
Possible.
yeah, we encourage everyone who can turn on their cameras to turn on their cameras.
All right. Hi, Maria.
Okay. So yeah, we'll give people some time to turn on their cameras.
There.
Okay. Let's see.
Is that it?
Is everyone okay? There you go. So anyone else opening their cameras? There you go. Okay. Are we okay? Is that everyone? We're gonna take a photo now. Okay. So
All right.
just calling once again, if anyone wants to open their cab last minute, you can do so. 1, 2. Okay. I'm gonna go. There you go. Okay, so let's take the photo. So, who's gonna count down?
I can do it. I'll snap
Okay.
the photo too.
Okay.
Okay.
All right.
3, 2, 1, smile. All right. Got it.
Okay. So yeah.
I know we're all eager to learn more, but I guess let's park here and refuel ourselves for the next day.
But the adventure isn't over yet. We'll be resuming on July 29 at 2 p.m. So that's going to be next week. So everyone can have some well-deserved rest.
And we would also like to inform you that we also have the deadline for ACM Olympics coming up, where you can sign up to play Fall Guys or Valorant for some cash prizes, some cash money. So sign up if you're interested at this link that someone's gonna send in our chat. I guess I'll send it.
There you go. The deadline for that is actually at 11:59 tonight. So if you're interested, make sure you sign up. And until then, stay tuned to our announcements by following UPACM Fest's Facebook page. So facebook.com/UPACM Fest. That's where we might have some surprises in store for the people who go on there. Maybe some prizes, we don't know. We just have a few surprises for you guys there. And you can also see some announcements about ACM Olympics.
All right. So thank you for coming to today's journey. See you next week. This has been your host, Josh and Macy. Much ACM love. Thank you all for coming.
Thank you so
much. That's it for UP ACM Fest Day 1.
And we'll see you guys